And with that, we welcome you inside the Fairplex here in Pomona, California. It is day 2 of the DARPA Robotics Challenge. It's the finals of 2015. Mike Am, Sarah Kustoff with you, and there's so much to get to after a huge, exciting day of action after day number 1. We had some Cinderellas all of a sudden emerge. Underdogs really caught on fire, and you were lucky enough to not only check out what was happening in the expo across the way, but also an opportunity to talk to a lot of the representatives from the teams why they were actually competing.
And beyond the track, the excitement was palpable, and you got to think about all the work they've put in since the trials. The moment that they had been waiting for had finally arrived, and it was certainly just so exciting to see the advancements they had made and the way in which they had found success with many of their robots.
You mentioned some of those advancements, trials of 2013 at the end of that calendar year, just sort of the strides that a lot of these teams have made. We're asking in this competition for 8 tasks to be completed in succession. Back in the trials, the tasks were done individually, so a huge dramatic change from that perspective, and all of a sudden these robots are actually taking off. There were some, I mentioned crowd favorites and some underdogs. There were 2 robots that we're going to see a little bit later that really emerged. Chimp from Tartan Rescue, that team really, clearly became very popular, and I think the crowd certainly was enthused every time. It was the only robot that actually fell and was able to get up on its own power.
Able to get up on its own power, and the team's not able to lift the robots up, bring it. So it was really, watching the way in which it has worked and what it was able to do, and to complete all of the tasks, complete the course. Certainly the crowd went wild, and we look forward to see what it has to do here today.
Well, the leaderboard is something that we're going to keep our eyes on, and once again, you can follow everything that's happening, real-time scoring on the DRC Finals app. Taking a closer look at that leaderboard, as we mentioned before, later in round number 6, Team Robo Simium, Team Nimbro Rescue, and Team Tartan Rescue. Those will be sort of the highlighted teams after day 1 of the competition. But as of how we got there, here's a closer look at some of the highlights from day number 1. Good morning, everyone, and welcome to the DARPA Robotics Challenge of 2015.
Ladies and gentlemen, start your robots.
That is impressive.
Oh, that's so great.
The vision for the DARPA Robotics Challenge, as much as anything, was, disaster response robot.
Tomorrow, we're going to get reseeded and take a closer look at some of these teams. Certainly some of those memorable moments from day number 1. I expect as the day continues to progress here, some of the teams that we saw early that add some moments where they can make some adjustments. Now all of a sudden they're going to be back on this track. They are just getting underway here in round number 1 of day number 2. And unfortunately, I have to say goodbye to you yet again. You will be over at the expo going through a lot of those demonstrations. I know you had a lot of fun hanging out with some of the kids and learning with them, which I think was kind of a cool experience for you.
It is, and we see different type of robots out there. So while you're not watching the robots out on the track, fans really should take some time to get out to the expo and see what's out there.
Doors officially open right across the way at that expo. Meanwhile, 4 tracks are exactly behind us. They are color-coded. It's the blue track, the red track, not to mention the green and the yellow. They are officially now underway, so I will let you get running and head over to that expo. But we'll take a closer look at what's happening right now on the blue course. Team AERO from Tokyo, Japan, had some moments on the track yesterday. In fact, in the round number 1 yesterday, the AERO robot actually cruised down the driving portion of the task. This is not a huge surprise. In round number 1 yesterday, none of the robots actually drove the car. The Polaris XP900. AERO made its way down, but actually got caught in the sand, actually had a fall, had to take the reset. So we'll see if the adjustments have been made from this team. In that middle jumbotron, we were focusing on the blue track, but we'll make our way over to the green track, and from Virginia Tech, it's Team VALOR. Their Escher robot is making some headway right now, heading down that driving portion of the course. From green, we'll now head over to the red track and just getting untethered. It's the Atlas robot, Team HKU. Collaborative effort here from a group of researchers and engineers, professors as well from Hong Kong, and right here in the United States at Waltham, Massachusetts. We'll make our way over to the yellow course, or it's Team Grit, the robot called Cogburn. It's a Colorado team, familiar with a lot of these challenges. 2005 DARPA Grand Challenge, they competed there, not to mention the 2007 DARPA Urban Challenge. So once again, this is a team that certainly is familiar with competitions. So right now on the 4 tracks, there's only one robot that's making some significant progress on the track. head over to green right now. It's Team VALOR, their Escher robot, once again, a team from Virginia Tech. Yesterday, Team VALOR was on the precipice of trying to make some moves in scoring. Unfortunately, unable to score a point. Did take the one reset. As I mentioned before, the team from Virginia Tech, we now get a closer look at their squad.
My name is Brian Latimer. I represent Virginia Tech, Team VALOR. Our robot is different, one, because it's all designed and built by students at Virginia Tech. The types of mechanisms that we have in there are unique so that the robot has a really large range of motion. Also, the software on there is software that we've developed in-house and a whole body control approach to that that makes it a lot more stable in walking uncertain terrains.
We're ready on this end.
Things are going really great. We've been able to test drive the robot through the course, collect a lot of data with our perception systems about the course so that we can bring that back and help us practice back at Virginia Tech. Also did some door manipulation yesterday, successfully opened a door. Yay! And now we're going to try some of the other manipulation tasks today. I think Virginia Tech is a smaller team. It provides you with the opportunity to really be able to adjust a lot faster to issues that may come up. For example, when you need to redesign a part, since we're doing both software and hardware design, if we recognize something that's an issue, then as a smaller, closer-knit team, we have the advantage of not only modifying things on the software side, but on the hardware side.
Thank goodness.
I think the community is very excited about the prospects of seeing these advanced robots just in their backyard. After the finals, we have some additional work that we're going to continue with the U.S. Navy on the SAFER program, which is a shipboard autonomous firefighting robot program. And we're going to use that to help sailors on board ships do maintenance tasks, as well as if there's some kind of damage or a fire event, the robots would be used as part of a hybrid force of robots and humans working together to recover or get the hazard conditions under control.
Once again, a look at Escher making its way down the course on green. This is the driving task, and of course, if Escher does cross that checkered finish line, still not going to earn a point. In order to earn a point for this task, you actually have to get into the vehicle and drive it down. We've seen a few robots decide to punt on different tasks and forego earning a point. If you don't drive, then you also forego the second task, which is egress, which is getting out of the vehicle. So max amount of points for any team that decides not to drive will be 6. That first real task to complete for a point for all teams that are on the tracks right now will be the door task. It's consisting of obviously opening the door and then making your way through the doorway. So while Escher continues to make its way down the driving task, we'll shift our attention now to the blue course. Team AERO yesterday during the competition really seemed to excel for about 95% of this task getting down. Got stuck, had to take a reset, and on the reset once again got stuck in the sand. So the team from Tokyo, Japan, hoping to make some adjustments on day number 2, and you can see sort of the same issue that they're having. As I mentioned before, this robot from Tokyo, Japan, and here's their team capsule.
My name is Akira Tajima, and I'm part of Team AERO. Team AERO is actually a joint team based on a partnership with the University of Tokyo and a company called THK. We actually decided to try to participate in the DRC finals last September. So that's kind of when we started putting pen to paper and started designing our robot. Of course, there's a lot of design challenges and changes that went along with that time. So it's not even a year since we started development. There are many challenges in preparation for the DRC. The end effector, or the hand, we thought was kind of a challenge for us initially. So we wanted to develop something that was lightweight and simple, that only uses one axis for a motor, with special linkages, and also a built-in controller in the hand. What makes our robotic unique is it uses what we call THK seed solution OEM robotic components. And what those are comprised of is a lot of linear actuators and motion control components. One of our main strengths for our robot is kind of the structure of it. As you can see, it uses 4 legs, which make it very stable. So actually, even when it has an issue or if it falls over, it still has the ability to get up. And it's very robust in that fashion, even though it is lightweight. After the DRC event, our main intention is to get some feedback and I guess use what we learned to develop a better platform for robotics.
So it looks like right now on the blue track, Team AERO going to take a reset. That's something they had to do yesterday. Take you through the reset process. Every time you see team representatives come out, put their hands on the robot, tether it again, that is a 10-minute penalty. They have 1 hour to try to complete as many tasks as possible. Some good news over on the green track right now. We told you about Escher the robot, specifically the team VALOR, some of the headway that it was making. As you can see, still making its way down the driving section. And in round number 1, it looks like Escher is performing the best of the robots. Check back in green, on green in just a moment, but we'll shift our focus to the red track. Team HKU. Mentioned a little bit earlier, collaborative effort between Hong Kong and Waltham, Massachusetts. Representatives from both countries working on this robot. They're using the Atlas platform. 6 robots domestically are using the Atlas robot. 1 internationally. That's a team from Hong Kong in this competition. Let's take a closer look at this team.
I'm ready.
My name is Robert Holm. I'm representing the University of Hong Kong. Our robot is Atlas robot. Our robot, which is built by Boston Dynamics, is currently being upgraded to go tetherless. So far, we have developed combined motion control on both arms, and also we have model fitting for our object pose estimation, which turned out to make our manipulation more efficient. We also improve our software in terms of this networking communication ability, which is, we call it net tunnel. Working from a team in Hong Kong, we got many challenges, logistical challenge. As you know, bringing the Atlas here may take us 7 days, because we actually bought this from Boston Dynamics. So they do the maintenance, they do the repair, they also do the upgrade. Those might take some time for them to fly over to Hong Kong to do it for us. So there's time delay, right? Also, there's some material like the drill. It will be very easy to get in US, but it's extremely difficult to get in Hong Kong. We are trying to establish Hong Kong U as a top-tier school in robotics. We believe robotics will be increasingly important in the future. So to compete internationally and be recognized in robotics, we need to compete with the world best. After the final, Hong Kong U will continue to grow its work in robotics. We will focus on manufacturing, healthcare, and service.
Once again, a closer look at what's happening on the red track. Focus on Team HKU to keep you updated on what's transpiring on all 4 tracks right now. Blue, once again, Team AERO taking a reset in this competition. Had the same sort of issues yesterday on day number 1 in round number 1. Over on the green course, once again, it's Escher still making its way steadily. Got to cross that checkered line and then move on to task number 3, which would be the door task. With that said, we head to the yellow track on the large Jumbotron in the middle of the field. Team Grit, Cogburn, Colorado team, once again very familiar with these DARPA robotic challenges. Competed in the 05 DARPA Grand Challenge and the 2007 DARPA Urban Challenge. Here's their team.
I'm Carl Castleton, and we are Team Grit. Our team name and everything is all based on that kind of Western idea of true grit. We are a gritty team. We are just a team that will just keep going and going and going, no matter what. Our robot name is Cogburn. What makes our robot unique is that it is completely it's our own build, and it's actually intentionally built in a way that has more affordable parts used on it. So we're really trying to make something that if we published how to build this robot, that people could actually achieve it and produce it. I think we have the lightest weight, least expensive robot here. Not because we couldn't chase down sponsors, it's more like we didn't want to build an expensive machine. We wanted to try and see what we could do, making it more affordable. Robotics, I think, inspires kids a lot right now because instead of explaining that you're writing code, you're making a website, or you're speeding up a database, it's when you see something move with some code that you wrote, it really inspires kids.
Servos published IP.
Our greatest challenge was in the trials, we had designed a robot that was very lightweight. We were like 30 pounds, easily the lightest robot in the challenge. We were a little bit top heavy, and what we were doing was we're burning out these fairly expensive components for us. They're like $500 a piece.
Oh, broken arm.
And so what we tried to do is design around that. And we spent about a year trying different stuff. We eventually had to abandon something that we had spent an entire year on. And so the legs that we're going with are legs that like designed 3 weeks ago. I mean, they're just conceptualized 3 weeks ago. They're implemented, laser cut, put together, software's written for them all in that amount of time frame. Again, with this volunteer efforts, nights and weekends. It would be like winning the lottery for us to win. Our chances are like that. Not zero, but not good. But that's not kind of our point. What we're trying to do is say, what could we do? What does work, what doesn't work in this more affordable arena?
Well, that was a look at what was happening on Team Grit over on the yellow track. Really an incredible accomplishment when you consider they're even qualified with some of the challenges that they had. Volunteers making up that robot versus some of the other teams that are out there that are well-funded, international in some instances as well. But on the Jumbotron, we're focusing in on the green track, Team VALOR. Heard some cheers in the crowd once they crossed that finish line. You can keep clapping for Escher. Once again, the team from Virginia Tech trying to earn its first point of the competition. If you're confused by that, this first task has to be a drive. So all 4 of these robots punting on that task. The second task is egress, which is actually getting out of the vehicle. Most of the robots in this competition on day number 1 struggled with that task. So because Escher did not drive, still looking for its first point. As we eye down the door task, fairly straightforward here. Robot must grasp the handle, push the door open, and you can see the yellow tape on the ground. As soon as the robot crosses that tape, officially, it will earn its first point. Once again, getting a closer look at what's happening on that green track. Escher still trying to earn the first point of round number 1 on day 2 here. I want to focus the attention just briefly on what's happening for Team AERO on the blue track. They're going through what's called demo mode. So they are essentially still going to go through these tasks here, but it's not going to count. What demo mode entails, they will still have full communication with their team back in their team garage. What makes this competition very difficult for these robots is when you see the robot get through the door itself, what happens then is what we call decommunication. So the robot is getting information and commands from the team that's not too far away in the team garage. What happens when they cross through that door, the communication lines are severely altered. So only bits of information are going both ways. So I compare it to like being on a cell phone where you only hear a certain word every couple seconds or so it's really hard to make out what the other person is trying to say. So the commands coming from the control center for these teams to the robots become very difficult. They're trying to mimic what happens in natural disasters. So right now, on the blue course, Team AERO is going to have full capabilities to communicate with its robot, unlike what we're going to see on the green track with Escher right now. As soon as Escher gets through, assuming it gets through that door, the degraded communication will take place. I want to give you an idea of what's happening for at least some of these teams in the team garage. Over on the green track from Virginia Tech, it's Escher, once again trying to make its way through the door. This is actually the screen that the engineers and the team representatives are looking at back in the garage. So they're trying to figure out exactly the movements that are necessary to go and open this door and then command the robot to grasp the handle, turn it, push it, and then once again walk your way through the doorway. But once again, we'll check in on Escher in just a few moments. You can continue to watch his progress over on the green track, but Sarah is standing by in the expo right now. First interview of the day, and it's an important one. She's standing by with representatives from NASA.
Yeah, that's right, Mike, here at the NASA exhibit with Sam and Chris. And let's first start out, Chris, with you, with Valkyrie. Participated in the DRC trials. Tell us a little bit about the robot and just the goal and the vision of what you see out of it.
With the goal and the vision of Valkyrie is to
All right, having some issues with the microphone with Sarah. We'll try to check back in just a few moments, but let's take you back to the green track and a closer look at Escher. Looks like we have some movement on the red track. We'll talk more about that in just a few moments, but the technical issues have been resolved. Sarah?
Thanks so much again. And Chris, we're going to try that one more time here, but you were speaking about Valkyrie and just the vision, the goal, and the expectations.
So the vision we have for Valkyrie is one that's very similar to what the DRC is, like I was saying before. The DRC was created to advance the state of humanoid robotics and just push together a lot of these technologies that already exist in disparate various forms and get them into a useful platform. And that's one of the goals that we have with the Valkyrie platform as well. Our focus being NASA is obviously a little bit more towards developing these for a space purpose, but
I figured you could do that
overall just having a better robotics community is like a better, people doing that kind of research is good for NASA, it's good for DARPA, it's good for everybody.
Absolutely, and Sam, just expanding on that, also looking forward, you guys are going to have a NASA Robotic Space Challenge now to spin off of the DRC finals here?
So yeah, that's exactly right. We're really excited about what's been going on here with the DRC, and so NASA's wanting to take advantage of that and start to leverage off of it. So we have a two-part thing that's coming up. Through the Centennial Challenges program here at NASA, we're also going to be offering up the Space Robotics Challenge. So that we're looking to start here sometime later this year. As a precursor to that, we do have a NASA Research Announcement Opportunity, so an NRA out, and what it's going to be open to all of the university teams that are competing here at the DRC. They'll have the opportunity to submit proposals, and we'll select from there, and we'll have two R5, two Valkyrie platforms, like you see back here behind us, and that Valkyrie platform will be available to those individuals or to those teams to continue to do the research, to continue to advance humanoid robotics technology, as well as humanoid robotics software control systems. And then we'll take advantage of that and have that as a platforms where competitors for the Space Robotics Challenge could go there to start testing their software that they're preparing to enter into the SRC Challenge.
And Sam, probably broad and can go in so many directions, but what do you envision, having a robot in space and just the exploration, what type of opportunities would that open up for you?
Right, so with this SRC, the things we're looking to do is to advance the technologies associated with the same difficult tasks that we're seeing here in DRC and take it to a different platform, a different arena, space exploration. So the handling of soft goods, cables, soft stowage bags, the ability for a robot to be able to exit a hatch and go downstairs, the ability for a robot to be able to possibly swap out electronic units or maybe swap out a rover tire on a rover that we have on a planetary surface. So all of those tasks that we would want to be able to put a robot into the platform area as opposed to a human is things that we're looking to do.
That's awesome. Well, certainly fascinating, and Chris and Sam, we appreciate your time, and for all of you, if you have a minute to get out to the Expo NASA exhibit, certainly one that you don't want to miss. Mike, back out to you on the track.
All right, Sarah, we're looking forward to hearing from you throughout the course of the afternoon, not only in the Expo Center, but also on the track, getting an opportunity to talk to some of those teams. Speaking of the Expo, coming up in just a few minutes here, an opportunity to see some more technology. Robots are allowing new tactics and techniques and accessing previously denied areas during search operations. Canines, though, still the most useful resource in urban search and rescue. A properly trained canine, still the most efficient means to rapidly search a collapsed structure. So you have an opportunity to meet some of those search dogs from the California Task Force 2 and watch as they quickly locate a trapped person in our responder demo area. Once again, at the expo today in just minutes, 8:45. Might even get a chance to jump into a barrel and be rescued. That's happening over at the expo right now on the tracks. Over on the red track right now, it's Team HKU still trying to make its way. Had a little bit of a slow start, but still working its way down the driving task. But over on blue, I made reference to this before, in demo mode. So Team AERO not going to be earning any points for any of the tasks that it does complete the rest of the way. Struggled yesterday, didn't earn a point. Made headway though down the driving task, but got stuck 2 times. So this will be its first opportunity to try to complete some of these tasks, starting with door. Something that we talked about in our open, just the strides that these robots have made in about 1.5 years' time. The trials were at the end of 2013, and they were instructed to complete multiple tasks, but do them individually. What makes this finals very difficult is the aspect of the degraded communication, not to mention having to do these tasks in succession. Let's take a closer look at the trials and what we learned from them and how it's helping what we're seeing here today in the finals.
We welcome you, everybody, to the DARPA Robotics Challenge, the trials of 2013 on another...
The DRC trials were incredibly important because they helped us to establish a baseline for how good robots could be at the time. And so they helped us establish, here's where we're starting from, and now the question is, how far can we go in 18 months?
So what we learned in Miami is things that you just never really see in the lab, like wind gusts. Suddenly, it's 10 miles per hour winds. We've accounted for that.
What we learned in the DARPA Robotics Challenge trials was that the hardware that the teams were bringing to the challenge was in fact quite good. What we've learned now to do for the finals, because the hardware is taken care of, is to push the teams to develop more autonomy in their software. And so we've cut the cord, we've cut the power cord, we've cut the communications cord, and we've cut the safety cord. And now what we need to do is to say, okay, with all of those cords cut, how can you make the robot work semi-independently from human beings, despite the fact that communications is not so good in between the two?
Since the trials, we've been focusing heavily on making our system more robust, better at localizing where the robot is, improving the ability for the robot to finally position its hands where they need to go to manipulate objects.
I think we've learned a couple things this week watching the teams practice. The first is that not very many of the teams have practiced falling down yet. In fact, we only saw one robot fall down the whole time, and that was by accident. And so I think the teams have a lot of work to do, doing real testing, having the robots fall down and then get back up.
Now it's more stable, more reliable. Now it can fall safely, stand up on its own. And we did a lot of rapid prototyping for testing different things. In particular, we have different type of hands. We're testing different type of hooks and end effectors to see which one is more effective. The structure is much more stable. The knee is much strengthened so it can walk up steps and handle rough terrain much more effective.
The other thing we saw is that the teams aren't going quite as fast as we had hoped, and so I want to change the challenge just a little bit to make it so that they're incentivized to go faster. And so right now we're anticipating coalescing some of the tasks to be together so that there's not quite so many tasks to get through, even though the variety will still be the same. And we think that'll give the teams the incentive to go a little bit faster through all of them. We've seen a number of teams, particularly from Korea and from Japan, really step up to the plate and work very hard to make their systems a lot better than they were before.
We changed everything since the trial, everything possible. In trials, we met very many problems on our robot. So the first one is joint capacity, joint ability. The more powerful now, we equip the air cooling system, the more powerful hands, and the radar and vision, the head system is very new.
Since the trials, we've mostly worked on improvements to the software. We have been working on adding more autonomy to the system so that the robot will be faster by doing more things itself, and so that it will be more robust to restrictions on communications.
We've now got stereo vision, laser radar, and we've kind of beefed up the visual system, so almost entirely new.
My expectation is that some of the teams are going to do very well. I know that some of the teams will have harder luck or for whatever reason won't do as well, but from what I've seen, I think we have some very, very strong teams.
So as you can see, some major strides from a lot of these robots as we take you to the blue course. And Team AERO, moments ago, figuring out a way to open the door. Do not forget, Team AERO in demo mode, so will not be earning any points for any of these tasks that it does complete. Yesterday, we did not get an opportunity to see this robot get to this point, as it did get stuck on the track 2 separate times. So we'll see if Team AERO is going to be able to carry some of this momentum through the door and now face this valve task, which is spinning at 360 degrees. You can see a piece of tape at the top of that handle. Might have jumped the gun just a little bit, something that we have seen other robots in the competition do, and that's skip tasks and move on to different ones, and it looks like Team AERO has done that. Typically the order would go from door to valve to then wall. Wall's been the task that most of these robots have opted not to participate in when they have skipped. But Team AERO right now heading to one of the final components. In fact, it's the 7th task out of 8, the rubble task. Robots typically during the portion of the task would earn a point. They can either choose the left side or the right side. You can go over the debris, walk the debris, or even move the debris. As long as you get to that other side and cross the yellow line, that would potentially give you that point. You can continue to watch the progress of Team AERO over on the blue track, but we'll send it over to the expo right now on our Jumbotron, where Sarah Kustoff is standing by.
Thank you, Mike. We're out here at the first responders demonstration area, search and rescue with the canines. I'm joined by Dennis, Tim, Rugby, and Stetson. And first, Dennis, if you could just explain, we often see these dogs, but what's just the purpose of them and the use that you have with them each and every day?
Well, I think Rugby's an answer for you, but what these dogs are used for are for live human scent. So they find the live victims that are hiding, and they alert on them like he's doing right now. And then we bring in our technical search, which could be search cameras, robots, and all that to detail it out and actually find specifically where that victim is so we could rescue.
And Tim, we're going to, if we can both have you let Rugby and Stetson get going, but just walk us through exactly what this course is and the track and how it is that they're able to accomplish this run.
Okay, on the first course, Rugby's going to climb the ladder, go across the board and come down the other side of the ladder. And a lot of times we'll use ladders, like let's say we need to get him into a building that's like been pancaked and we need to get him up onto a second floor. We'll throw a ladder, the dog will run up there and go do his thing. After that, we're going to go through a tube, which would simulate other things like small areas, confined spaces, etc. And then we'll finish up with the dogs finding the victim that's hidden in one of these boxes.
How long does it take to train a dog to do these type of activities?
After they're formally trained by the place where we get them, we continue to train with them at least 4 or 5 times a month.
How long have you had Stetson with you?
Actually, I'm dog sitting.
Okay.
Stetson's not my dog, he's Andy Alvarez, who just got back from the East Coast. Stetson's 7.5 years old, and Rugby's 5 years old.
And I know that Dennis had mentioned it a little bit, but what's the use of the robots? How do these dogs and the robots work together?
Well, the dog could sense a live victim, and then he would bark. We'd go mark it on GPS, and then the robots could come in. Let's say they breached a hole like that. You could send something in there to go find the victim.
Awesome. Well, this is incredible. Great to see what these dogs can do. And again, out at the Expo, so many different demonstrations you could see out here. Mike, certainly a fun one. And I think the interview next needs to be with the dogs because these guys are barking. They're ready to talk.
Ready, Stetson? Let's go.
Still waiting for Sarah to get inside one of those boxes, see if one of those dogs will be able to find her. Let's check in on the red track right now. Team HKU had some slower moments to start things off, but starting to chug a little bit closer to the checkered finish line. While Sarah was doing the interview over at the Expo, over on the blue course, Team AERO was trying to make its way through the rubble. Instead, took a little bit of a spill. Over on the blue track right now, Team AERO has done a reset and has decided to try its hand at the surprise task. 3 different options available on rehearsal day. So 2 days ago, it was a push button task. Yesterday, it was a pull switch. And today, it is a pull plug. Nice win for Team AERO on the blue track. Looks like officially accomplishing the surprise task by successful pulling the cord out. Just a couple seconds away before round number 1 is officially in the books. Just to keep you updated, no points scored by any of the robots officially in the standings in round number 1. Sort of mimics what we saw yesterday. The point system and the seating in terms of rounds played out rehearsal day on Thursday. How the robots finished during the course gave them their seating for yesterday. Their results from yesterday are impacting when we see them today. So some of the stronger robots, the ones that we saw really score some points, like Chimp from Team Tartan Rescue, the only robot to tally 8 total points, they're going to be at the end of the day. In fact, they'll be competing in round number 6. So round number 2 is going to kick up in about 45 minutes or so, and we'll see 4 new robots hit the course. Team AIST NATO, Team Trooper, Team HRP2, and Team Hector will all compete in round number 2. Welcome back out to the DARPA set here. Round number 2, almost around the corner. Once again, we're going to see the Cheetah Robot spot coming up in just a few moments' time. But Pam Melroy, who's the office deputy for the Tactical Technology Office for DARPA, joins me here on the set. What do you make of what's happened over the last couple days here?
Good morning. I think it's fantastic. It's incredibly exciting to see all the students working together and working on technology.
Now, I know you're a former astronaut, so tell me what's attracted you to take the job at DARPA and have this role.
Well, I think DARPA reminded me in a lot of ways of being an astronaut. We work on technologies, and we're thinking about the future and how we can do things better for people in the future. So it just felt like a really good fit.
And I know you mentioned sort of being around younger students. We were hearing from Sarah throughout the course of yesterday, and we're going to hear from her today. And I think one of the things that stood out to me is the fact that you have so many elementary school kids, high school kids. In fact, 1 or 2 of our teams actually have high school students that are working on some of these robots. How important is that in sort of the development of this technology over the next couple decades?
I think it's absolutely critical. I just think that technology is needed for all the major breakthroughs. You can just see here this particular application, which is about humanitarian assistance and disaster relief. When I was at NASA, it was about exploration of our universe. But these technologies don't just happen. Somebody doesn't, hand something to you and then you get to use it. You really have to understand it. It's critically important for this generation of students to study in science, technology, engineering, and math, because that's how the world works. And you have to understand how the world works if you want to change it. And it's very inspirational for me to see these students who will be the leaders in the robotics field in the future getting this experience.
What's your message to a lot of the students that are at the expo that are going to be behind us watching some of these robots and are sort of piquing their interest about potentially moving into a field like robotics or some just broader technology?
I think it's important to know that even though it's super cool just to watch a robot, technology is at its best when it's focused on achieving something. Very, very important to understand that. In this case, we're building technologies that are focused on humanitarian aid and disaster relief, but engineering is at its most exciting when you're trying to solve a human problem. And I think that's what I want people to understand, especially the students, is that engineering is not just cool hardware. It's actually about solving a problem for the human condition.
When we talk about the environment, the fake environment that we've created for these robots to try to aid potentially and really revolutionize sort of the technology that we do use in natural and man-made disasters. What do you hope, though, when this competition is complete in a couple hours and we have these robots that are going to be awarded $2 million, $1,500,000, what's the end game here? What do you want to see? What do you want to come out of an event like this?
Well, I think of the setup that we have here just like the simulators I used to fly. So I did hundreds of hours in a simulator of the space shuttle and the space station before I went to space. So my hope is that the winners and actually all of the teams keep practicing over and over in a simulator, and that maybe, just maybe, they'll be ready when the real game day comes and they can go save lives.
Did it get monotonous for you? Hundreds of hours in a simulator. It's not the real deal. I work in sports, and I hear from athletes, and I talk to coaches all the time. We hear about practice and the importance of that. A lot of players don't want to always practice, and yet for you, I have to imagine that was absolutely critical for your career and sort of getting into space and taking part in activities like that.
That's exactly right. You have to plan for everything, because the thing you didn't plan is the thing that's going to happen. So the more you rehearse and the more you practice, the more ready you'll be in a real day, in this case in a real disaster, to be able to solve problems.
Did you feel like you were always prepared for any situation after all those hours in the simulator?
Well, when the thing you weren't expecting happens, it can be a little bit of a surprise. On my last flight, we had a failure, a big solar array that was needed to provide power for the International Space Station didn't deploy properly. So we had to pull together and do an emergency spacewalk. But because we had hours and hours of training, we were able to figure out how to stitch tasks together that we had done previously in order to solve the problem and safely repair the solar array and deploy it.
I think about the competition behind us and the preparation that it entails. Some of these robots, I think it was Thor maybe yesterday or Thursday, actually injured its shoulder, and you have to on the fly then all of a sudden figure out, hey, what's that next step? How do you make those adjustments out there on the track? And even in situations like this with the degraded communication, sort of what happens if, we showed a video a little bit earlier where one of the team representatives even said, hey, you have to account for all these different variables. Maybe there's a wind gust that you didn't expect on all these robots. That technology, it all comes down to preparation.
That's right. You just have to practice and practice, and hopefully if something unexpected happens, you kind of reach into your tool bag and say, I remember I did something like this once before, let's try that.
Yeah, well, Pam, appreciate you stopping by with us. Obviously, it's a great event for DARPA. We are certainly looking forward to seeing how this competition does play out. Thanks again.
Thanks, Mike.
Once again, round number 2, just minutes away here. We will see Cheetah Spot, the robot, be on this track right behind us. It's going to showcase some of its speed. Some significant news coming out of the Operations Center. Team MIT yesterday finished up their round with 6 total points, but as you look at the most up-to-date leaderboard, which by the way you can find on your phone if you download the DRC Finals app, it is real-time scoring, but MIT was awarded the point for egress from yesterday. That actually now puts them in 4th place as you take a closer look at these updated standings. Once again, only one robot earning all 8 points. That was that Tartan rescue robot called Chimp. Round number 2, as they're getting set, it's coming up in about 30 minutes or so. Well, back on the DARPA set, Mark Raybert, who is from Boston Dynamics, joins us in just in a couple moments. We'll see Spot on the track. Tell me about this robot.
Spot's a quadruped robot that we've been developing for the last about a year. It's the last in a long line of quadruped robots that we've built for DARPA. We started about 10 years ago building Big Dog, then we did the LS3 and the Wildcat, and now we've been working on Spot.
So now we're taking a look on our Jumbotrons, and once again, this is happening on our infield track about some of the movement, and right off the bat, it's sort of unique because we've seen some other robots. Take me through exactly what is allowing for such unique mobility.
So the cool thing about Spot, obviously it has legs, and legs let a robot go all over the world, just like you can go with your legs, whereas wheeled things are kind of limited to the places they can go. So we're excited by that. But the key thing about Spot is its sense of balance. It's got a gyroscope on board that lets it sense how it's moving, and that lets it position and torque its feet to keep it balanced even when it's on rough terrain or being disturbed.
We've seen some other robots. We had a demonstration yesterday where we were throwing dodgeballs and the robot was still able to keep balance. When you're talking about terrain and rough terrain, how does Spot handle, obstacles that might be placed in front of it?
Well, it has sensors on its head, both a range sensor and a stereo sensors that lets it detect obstacles and use that to plan paths around them and things like that. It can go upstairs using those sensors. It can go up and down hills.
How fast is Spot?
Spot's only medium fast at this point. I think we've had it about 5 miles an hour. We've had other robots that can go about twice that fast. Actually, our Cheetah robot went 30 miles an hour, faster than Usain Bolt, but Spot's a little slower. One of the things we did with Spot is we made it a lot quieter than the previous robots. It's quieter, but it's also smarter. Here you can see it changing gaits. So there it was using a jogging gait. It can turn in place, as you're seeing now. It's walking with a pacing gait, which means that I think it's actually trotting here, but it can pace. There he switched it to pacing. Now it's walking. So there's a whole repertoire of things it can do, and depending upon the terrain and disturbances, it adjusts itself to do that. Here it's skipping, so it can play hopscotch.
What's the end game? What do you want to accomplish with a robot like this?
Our goal right now is to make robots that can go anywhere on the Earth, and that means up a mountain, on a trail, through your kid's messy bedroom, just any place where the terrain wouldn't let you get with old-fashioned wheeled thing.
You mentioned that Spot is more quiet than some of the other robots. Technology-wise, how much did you lose in terms of speed, for example? You said Cheetah goes 30 miles an hour faster than Usain Bolt. I would imagine that Cheetah's probably also a lot louder.
Yeah, the 30-mile-an-hour robot was very noisy, the noisiest one we ever made. This one's quiet by both compromising on how far it can go. There's not necessarily a speed limit, but although it doesn't go as fast as the Fast Runner. So you can do, for any particular design, you can put together a combination of range, speed, noise, and then come up with a design that'll meet the goals of the problem.
What is the range on Spot? How far can the operator
It can go a few miles on one battery charge.
How long is that?
About an hour and a half.
So an hour and a half, you can take off and just rock and roll. Is there any other unique characteristics? Because we've seen some other robots that look like Spot. They trot, they dance, and whatnot. What makes this one particularly unique compared to some of the other demonstrations we might see later today?
Well, I think the level of agility as Spot is, certainly it's a new level for us. We've been working on getting these robots more and more capable, and Spot has a range of things it can do, and the quality and sort of precision in them that really is a cut above everything else we've done.
Well, Mark, we appreciate you demonstrating Spot for us. Certainly an incredible robot, one of the cooler looking ones, and I was personally a bigger fan of the skipping, a little pep in that step.
Thanks for having us here.
Fantastic. Well, once again, coming up in just a couple minutes time, it is round number 2 of the finals on day number 2. We're going to see obviously some robots trying to earn some points. We have yet to see 1 point scored in the competition. That's similar to what we witnessed yesterday. And here's a look at the most up-to-date standings. And if you're just making your way inside the grandstand right now, MIT, really the significant news here, Team MIT awarded a point for egress from yesterday, puts them now in 4th place. There was a Team MIT was one of the more popular robots, but after the DARPA officials went back to the video, saw the egress task, they decided to go ahead and award Team MIT that 7th point. So that gives them sort of a statistical advantage. Remember, the scoring, the $2 million on the line, it's your best score, best time combined between the 2 days. So it's something that we're going to keep our eye on. Once again, in about 20 minutes or so, we'll see round number 2 kick off. 4 more teams will hit the blue, red, green, and yellow tracks. We'll see if we'll earn our first points of the afternoon. Back here on the DARPA set, Mike Am, joined by DARPA Program Manager, Dr. Gil Pratt. Gil, great to have you back on set with us. It really was an exciting day number 1. Really, as the day progressed, we saw some underdogs maybe that we didn't anticipate really to do all that well, sort of bolster up the standings. What was your impressions after what we saw yesterday?
Well, I absolutely loved yesterday. It was just an incredible day, very, very exciting and fulfilling for me. We didn't really know how the teams would do, whether they would run into lots of difficulties or do well. But I think overall it went great.
What was your biggest surprise after that first day?
I would say that so many cars, so many robots successfully drove the car. I really like that.
Were you surprised with some of the strategy? I did notice that some of the robots that are towards the top of the standings decided to skip around some of those tasks and then work their way back.
Yes, so we had not anticipated that. We defined the communications degradation in a way that at the beginning of the hour, if they're inside the building, that degradation is very bad. So the blackouts last a long time. And then as time goes on, the time between the blackouts keeps going down, so it becomes easier. The teams are very smart, and they figured out something that we didn't anticipate, and that was, well, let's do the easy tasks first while the communications is hard, and then we'll come back to the hard tasks.
And you and I talked about what those hard tasks were going to be, what we thought they were going to be. You said driving was going to be difficult for them, egress and stairs. Right. And yet, because of that degraded communication, I just assumed that the wall task was the one that everyone was skipping because of the precision that was required. So they waited, is that sort of the strategy behind that, wait on a task like that because of how specific that task is?
That is exactly right. You have to control your hand and the forces that you use really carefully so that you don't break the bit. The drill bits that we're using are actually very, very thin, and you've seen some of the teams when they bang it up against the wall, the wood part of the wall, it just breaks the bit off. So the teams have to drill very carefully and consistently, and if the communications is better, that's easier to do.
MIT, Team MIT, they've been awarded a point after yesterday for egress. Take me through the decision-making process and what you saw there.
So we received a note from MIT last night saying that they believe that they deserved an extra point. What happened to them, if you remember, is that they were in the vehicle and the robot began to get out of the vehicle, and then suddenly it got the shakes. And you watched its legs and they were shaking around in this crazy way, and it suddenly just fell out of the vehicle, shaking its legs all the time. Our rules are very precise on this, and the robot must land inside of the yellow box that precedes the door. It must have all points of contact in that yellow box preceding the door in order to be awarded the point for egress. This was not the most elegant egress that you might imagine, falling out of the vehicle. But just like in football where you go and you look back at the videotapes, we went back and we looked at every single frame of the video, and there were actually several frames where all points of contact of the robot were inside of the yellow box, and so they deserved the point, and we gave it to them.
Well, round number 2 is officially underway. We're going to take a closer look at what's happening on the tracks. Once again, 4 different tracks. They're all color-coded for you, blue, red, green, and yellow. I still want to talk to you just about some of the scoring because, and especially that fall, there was at one point towards the end of the day where Chimp the robot from Tartan Rescue was was a crowd favorite. I mean, that was the only robot that successfully, at least in my mind, fell and was able to get up on its own power. And when it fell through, it actually fell through the doorway. Now, it didn't totally cross their line. It eventually made its way through, but it reminds me of what you're talking about and what you're discussing with MIT. And once again, taking a closer look at the blue track right now, and that is the robot HRP2 Plus. But it was certainly just impressive to see Chimp able to do that.
Yes, it is very good. We had always wanted teams that fell down to have to get back up on their own. Calling a reset is supposed to be a method of last resort because the penalty is really severe. You get 10 minutes of time you must take at minimum, and you also have to move the robot back to the reset point, which is outside the door in the building if you've been in the building. And if a reset happens while you're driving, you get reset all the way back to the very start. So it's a very severe penalty. Getting up by yourself is much, much better.
Dr. Pratt, we talked about seating before the rehearsal day, and it looks like on the blue track right now, we are going to get our first point of day number 2, and yep, that is official.
Wow, very
we'll
fast,
find
yes.
out how it performs in
very
egress.
Good.
You said you were surprised about how fast or how many teams were able to successfully drive. It's amazing how fast some of the teams are driving that car.
Yes, absolutely
as well.
Great. And they managed to stop before they hit the wall. We do e-stop the vehicle, so we have our own controls to stop the vehicle from proceeding, but they're actually controlling it very well.
So the official first point on day number 2 on the blue track. I made reference to the seating. We had an opportunity to speak before the rehearsal day. You said, hey, the seating is going to play out depending on how the teams do on rehearsal day. Round number 2, now the stronger teams we expect to see a little bit later, but in round number 2 yesterday, team IHMC Robotics, the Running Man robot, really performed well. It sort of stepped at the top of the standings throughout the course of most of the day. Was it adjustments that they made from rehearsal day to day number 1, or how do you explain sort of, I don't want to call it a misseeding like it's the NCAA tournament for basketball, but in some ways it almost plays out like that.
So a thing to remember with these robots is that they are prototypes. And if the robots fall, there's a reasonable chance that they may get damaged and then will not be able to proceed. So every one of these teams has been worried that their robot might get damaged during rehearsal day and then be hard to fix for the next days. And no team wants their robot to be knocked out of the contest because of damage. So teams were very conservative on rehearsal day. They were somewhat conservative even yesterday on the first day of the contest. I think they'll be not conservative today. They'll be very aggressive now because they want to score the most points. And if the robot breaks in the process and they have to take home a broken robot, that's okay. They're just going to try very hard.
And they can still work off of their results from yesterday in terms of that official, so it is the best of both days.
Exactly right. It's the best score from both days.
Dr. Pratt, it is always great having you on the set and giving us the lowdown on what's happening behind us. So I know you got to get running. You're a busy man. We're going to keep our eyes on these 4 tracks right now and see who else scores some points.
Great. Thank you very much.
Once again, on the blue track right now, still our first point that was scored. They're going to punt on, it looks like, egress, but let's move over to the red track right now where we continue to make our way. It's Team Trooper doing the driving portion of its task. Well, currently on the red track, we're watching Team Trooper. Sarah Kustak is standing by with one of their team representatives.
First, just what's your evaluation of how your robot is performing thus far here today?
Well, so far this morning, our robot is driving much more smoothly than it did any other day, so I'm very happy with this. We still have another set of barriers to go through. We'll see some starting and stopping as the team in the garage is planning around that. They're definitely erring on the side of caution because we had some problems yesterday. I think we can have a lot more points today. We just need to run the plans that we've made out.
Yeah, what's your takeaway? Talk me through just the dialogue last night, and as you headed into the run here today. What's the takeaway from yesterday and things you try and look to adjust and improve upon?
Well, certainly in our lab, one of the hardest tasks to practice was driving, just because of the space we had available to us. So unfortunately, driving is also the first task of the day. So you need to get through that before we can get to all the great stuff that we've had a lot more practice with. So we learned a lot driving yesterday, and we applied a lot of those fixes. We have a better calibration scheme for our throttle. We had a better strategy for positioning the vehicle before it actually starts moving to ensure that it's in a better shape to move through the barriers a little more easily.
And you did make it through the door. You almost made it to the valve yesterday. Was more of it about the time to actually get there and the time that you didn't have remaining to finish the other tasks?
That's right. We spent so much time driving yesterday that by the time we got through the door, we had just about 10 minutes left. And so we went through the door and straight to the valve and began turning that. We can move fairly quickly walking once we're inside. So I really hope we have a lot more time left after the driving during this run.
Well, you don't have a lot of time now, Todd, so we certainly appreciate it and let you get back to work. Good luck the rest of the day here.
All right, thank you.
All right, Mike, back to you.
All right, Sarah, we'll shift our attention over to the green track right now, where team HRP2 Tokyo is tethering out of the car. Keep in mind, the egress portion, you will now be penalized a 10-minute penalty. Once you see team members out on the track helping the robot complete a task, it's a 10-minute penalty. So while the blue team, for example, was able to drive successfully, as will the team on the green track, HRP2, both of these teams will not earn that secondary point because they did not successfully get out of the car. In fact, now they'll be penalized 10 minutes and will be eyeing down task number 3, which is the door. We just heard from Sarah down on the track with Team Trooper. She's been all over, not only on the track, but also at the expo. And coming up at 10 o'clock, so just a few minutes away, opportunities to see some very cool demonstrations. In fact, over at the Endurance Tent Expo, there are 2 treadmills, 2 robots, no power cords, and we have all day to see who the last robot is standing, who can last the longest. It's the high efficiency platform. Once again, that starts at 10. The endurance walk starts around that time. And then another opportunity at 10 o'clock to see the unmanned area vehicles in the expo as well. It's an unmanned area vehicle that's going to take off at 10 o'clock. It's going to demonstrate sort of some self-healing network as one of multiple trajectories that the robot was going to be able to take. And then also at 10, Johns Hopkins University Applied Physics Lab is going to demonstrate a collaborative operation between their mobile 2-arm manipulation platform. It's Robo-Sally and an unmanned aircraft overhead using the aerial and the ground perspectives to perform searches and rescue tasks in a simulated industrial disaster scenario. That's very cool stuff. Once again, in the unmanned area vehicle area of the expo, that starts at 10 o'clock. And then again, 15 minutes later at 10:15. Are being told over on the red track, Team Trooper is requesting a reset, so we'll get some details on that in just a few moments, but a closer look at the team is right now.
My name is Todd Danko. I represent Team Trooper. Team Trooper is unique because we are the only large company that's participating in the DARPA Robotics Challenge. And we're looking at this as an opportunity to help improve the technologies at kind of a lower level that ultimately can make it into autonomous systems that maybe we'd be putting into outer space or underwater. As you know, if the robot were to fall, you're prevented from proceeding to the later tasks unless you have a way of getting up off the ground, which is incredibly challenging with the robot that we're working with. So the challenge is designed to build robotic systems that can help humans in bad situations, either help try to change the course of a disaster or help clean up after a disaster. These are things that affect all humans. It doesn't matter what country you're in. My friends and family usually hear me talk about the robotics competition and don't realize how really big this is until they come along and see something in the media about the DARPA Robotics Challenge. That's when I always get a response like, "No way, you're part of that," or "That's awesome, that this is something that you're participating in." It's very exciting. The community has been very supportive of Team Trooper. I think that the community as a whole will be the winner of this, regardless of which team gets the most points. Robotics are the future.
Well, there was a look at what was Team Trooper over on the red track. Meanwhile, some good news over on the blue track, where Team AIST, NATO, has opened up the door, has not exactly earned that second point just yet. Remember, it did the drive successfully. That was 1 point, punted on egress, so they do not get a point for not getting out of the car. They reset, 10-minute penalty. Now they have to do the approach to the door, open it up. That's exactly what's transpired. But to earn the point, you have to get through the doorway.
So FYI, yellow's running down there. They're back up.
Frozen back to you.
To the yellow track as we continue to track the progress over on blue. But for yellow right now, that's Team Hector embarking on the drive, creeping a little bit closer to that checkered line, just a couple more feet there, and as soon as it gets through, that would be its first point. Team Hector did score a point yesterday at the standings for this very task.
Bob, check. What's going on over
Some good news over on the blue track. That is now a second point for robot HRP2+. They've now doubled their point total. Yesterday, just 1 point after a successful drive, so it's certainly good news there. Let's shift our attention back to yellow, and we are creeping closer to Team Hector's first point. And there it is. Over on the green track right now, it's team HRP2 from Tokyo. And they earned their point for the drive, did the reset, so did not pick a second point up for egress. This would be a second point on task number 3. Progress being made over on the blue track right now for HRP2 Plus. This is the valve task. 2 points already earned on the blue track. Valve would make it 3. Task fairly straightforward. All you have to do is turn the valve 360 degrees. If you're looking for a marker indicator, you'll be able to see a black piece of tape at the top. It's a good opportunity to remind everyone what's happening in the team garages. They are the ones that are operating the robots. As you can see here, this is exactly what their screen looks like. Once they get through that doorway, degraded communication kicks in. And essentially what that means is to be able to tell the robots what to do becomes increasingly more difficult. Now during the drive, egress, and getting through the door, communication is just fine. Once they make their way through the door, that's when there's a breakdown. To give you an analogy of what that actually entails, imagine being on your cell phone, not being able to go and only hear every few words for a few seconds from the other person. Really hard to make things out. The best robots in the competition are the ones who are able to handle autonomy by themselves. So given a command in a short burst. So if you were in a club and it was dark and a strobe light goes off, there's really just a quick second to gather the information. The best robots create essentially what amounts to be a map. And that map is generated for the operators who are back in the team garage to then try to explain to the robot exactly what to do. And that's what's transpiring right now over on the blue track. Some action over on the green track right now, where the other team from Tokyo, HRP2, has successfully opened the door. Keep in mind this robot yesterday only earned 1 point, so potential for a second point now in the competition. Also some good news on the blue track. If you're watching on that monitor, it looks like the robot has come close to grasping the valve. Remember, 360-degree turn. Some of the robots, as they try to get through the doorway, some will walk straight through just like you or I would. Others actually turn their bodies, so they actually walk sideways through the doorway. Not exactly sure if that's what's about to happen. Meanwhile, on blue, you can see just a few degrees of a turn thus far, so a little bit more rotation is needed. 360 degrees in order to score that point. We'll continue to track the progress over on blue, but meanwhile green, you can see making its way through the door. Got to cross that yellow marker at the bottom. Once that's done, you'll earn the point. Second point earned on the green track for HRP2. That doubles their total from day one in the competition as we head back over to the blue course, where HRP2 Plus is almost complete with the valve task. Keep making reference to all the cool things that are happening over at the Expo Center right now. Sarah Kustok is standing by with more.
Look at you, right? That camera?
Yes, yes, and I am, Mike. Thank you so much. Here with Kurt Salisbury from SRI Robotics and Aaron Ames from the Amber Lab at Georgia Tech, and we're at the endurance testing demonstration here. And at first, Kurt, I want you to just talk to me a little bit about the robot, the goal of it, what you guys are pushing for as you created it.
Yeah, sure. So the objective of this whole event is disaster response robotics. And one of the things DARPA is pushing for out in the competition is enabling robots to do a variety of very important tasks to disaster response. Here what we're pushing for is trying to enable the robot to do tasks longer. So taking a particular battery and enabling a robot to go longer on that battery. And so we've done that by looking at a number of things. Every element of the hardware that consumes battery energy, we've looked at ways to improve that, get it more efficient, enable it to go longer, and then getting over into the control side of it, getting walking gaits that are much more efficient, much more natural as well. And so as a result of that, we've been able to get this robot. Yesterday it did many hours of walking, and we got a 2.5 hour stint. It went about 2.1 kilometers on just half of our battery capacity.
That's incredible. And you talked a little bit about this walking gait. I mean, when you watch this, I'm just fascinated by how human-like it looks as it takes these steps.
That's right. Yeah, I mean, the idea is to really capture the dynamics of the robot and use the passive dynamics. There's actually springs in the ankle that we're drawing upon to get more efficient locomotion. So to bring all these together in this kind of symphony of motion like humans do, right? And really in that way we can capture unprecedented levels of efficiency on humanoid robots. And this is, in my mind, it's kind of the view of the future, right? It's what we want robots to do 5 years down the line.
Thank you so much. We certainly appreciate it, and awesome to watch. Mike, we decided if you were going to walk for 2.5 hours, you'd at least need a Big Mac. So we're going to get you down here on the treadmill.
Hydration is the key, Sarah. It's all about hydration. She made reference to, we'll head back to the track right now, over on green. We've already seen 2 points earned. That doubles the point total for HRP2 after day 1. So a successful drive, got through the door just fine, and now looking at the 4th task, which is the valve. We saw this happen over on blue. Meanwhile, over on blue, if you are watching that screen as well, we've seen this before where some of the robots decide to skip and go out of order with those tasks. And that's exactly what's happening over there. So after the drive, the door, and the valve, over on the blue course, now make it 3 points scored total. The HRP2 Plus robot and its team has decided to skip the wall task, which is been a strategy used by a few of the teams that finished towards the top of the standings after yesterday. The surprise task, and it looks like over on green we're going to get that almost to that point, but a few more inches there. But to keep you updated on the surprise task, 3 possible options, and they've changed over the last 3 days. So during the rehearsal day, the robots had to go with a push button off switch. Yesterday in day 1 of the finals, there was a pull down switch, and today it's a pull plug switch. And the point has been accomplished over on the green track. So now make it 3 total points. A significantly better showing for this team compared to yesterday. We'll jump back over to the blue track right now. As I made reference to, a pull plug switch is the surprise task for this team. Once again, here's a look at what the team on the blue track inside the team garage, that's team AIST NATO, what they're looking at on their screen. Once again, the communication has been degraded. It will get better during the course of the hour, but still trying to create a virtual map for the robot so that it can go and try to execute this task, which is pull the plug out. Looking for potentially a 4th point. After day number 1, the HRP2 Plus robot, which is what you're watching on the Jumbotron on the blue track, only scored 1 point. Today, a successful drive, successfully getting through the door, and the valve has now earned them 3 points. Let's take a closer look at their team.
My name is Fumio Kanehiro. I represent Team AIST NATO. Name of our robot is HRP2 Kai. We have been working on the humanoid robot more than 10 years, and we tried various things like humanoid robots for entertainment or humanoid robot for some practical work, like collaborative work with human. But after 3.11, we couldn't provide any robot that can work in the Fukushima nuclear plant. After the accident, human cannot enter into the building, but the building itself is built for human. That means for us, a humanoid robot is the most appropriate robot to go into that building. We have been concentrating in development for disaster response. We don't have so much experience in the manipulation or measurement of environment. So this is a very big challenge for us to do various tasks of DRC. We didn't attend the trials, we just watched. But in trials, many of the teams used CAD models of the environment. But in finals, we cannot use CAD models of the environment, so we are preparing software that can work even if we don't have a precise model of the environment. So it's very difficult. We are now working very hard for the finals.
So that's a closer look at Team AIST, NATO. Good news for the team is for this surprise task, they have successfully unplugged the core. Now you can see 2 outlets that are there. This task significantly more difficult on day 3 than it was on the rehearsal day and even yesterday. Next up for the robot now is to plug it back into the second outlet. And over on the red course, Team Trooper, very close to scoring that first point. Good news for Team Trooper earning that first point. Yesterday they scored 2 points in about 56 minutes worth of work, so a little bit faster today, but we'll see if Egress, this would be the first robot today that would successfully get out of the vehicle. Just getting official word over on the red track. Team Trooper has been awarded 5 extra minutes. Certainly will help them potentially score another point. Meanwhile, over at the Expo coming up in just a few minutes, so at 10:30, Flyability will demonstrate the Gimbal, a collision-tolerant flying robot. It uses a protective frame to both fly and roll around in an energy-efficient manner. That demo in an unmanned aerial vehicle tent in the Expo starts at 10:30. I'll check back in on Team Trooper on the red course in just a moment, but back to blue we go as HRP2 Plus is trying to complete the surprise task. When you consider the difficulty and the precision it takes compared to some of the other tasks, really impressive what we're seeing here if it's able to complete it. A lot of the teams have opted to skip the wall task because of the precision that it takes and what's required. The HRP2 Plus robot, they also skipped the wall task, but you got to think in terms of that precision, it's just as difficult, maybe even a little bit more, and it looks like it's so close to earning that point. If it does go and earn that point, it would be a 4th point in this round. Keep in mind, they scored just 1 point yesterday. So another point has been awarded on the blue track. And it looks like we're so close to another point on the red course. This would be the first successful egress of the day. So right now you're watching Team Trooper on the large Jumbotron. They're on the red track. So close to successfully dismounting. Heard a couple oohs and ahs because of the plug falling out on the blue track. They were awarded the point. Even though the plug fell out, they still will earn that 4th point. So good news for Team Trooper on the red track. They officially earned that point. So over on the blue course, Rubble, the 7th task, that's what HRP2 Plus is now facing. So we'll continue to check in on the action on our 4 tracks, but over at the Expo Center, Sarah Kustok is standing by.
Thanks so much, Mike. Yeah, here with Albert, MIT demonstration of their robot Hermes. And what's been the approach, the design for this robot, Albert?
Well, this robot has two parts. We have the humanoid robot here and also the human interface side over where Zhuang's standing, our operator. And the design for this robot, it's designed for human-in-the-loop operation. So what we want to be able to do is, if we were to push on the robot and it loses its balance, we want the operator to be able to feel that. So we have some sensors in here that can detect where its weight is over its feet, and that gets fed over as force on the operator's waist so he can take corrective action. And of course, all of his actions are mapped back onto the robot so he can feel like he's really there in a disaster environment.
That's incredibly cool, and so many of these robots on the track, or some we've unfortunately see fall. We know robots do in fact fall. What type of challenge is it to have this type of balance and to have the improvements, advancements you're making with Hermes?
Well, at least with this balance, we know that we can take advantage of the human brain. You have something like 100 billion neurons, shaped through evolution, how you're able to learn, you have creativity, and a lot of this balance, these tasks are effortless for you, whereas they're quite difficult if you wanted to make a fully autonomous robot. For example, planning and doing trajectory mapping is quite difficult, whereas a human, we're not necessarily optimal, but we can get the task done.
Wonderful, Albert. We certainly appreciate your time and getting a chance to see Hermes here.
Yeah, thank you.
All right, Mike, you got to get out to these demos and see so much out at the expo, but for now, we're going to send it back to you and the blue track.
All right, Sarah, as you mentioned, robot HRP2 Plus trying to make its way over the rubble, deciding to go over the concrete. Two options for this task. You can go right over the concrete, go left over the debris. Doesn't matter, you can walk over it, roll over it. You can even move the debris. Just in case you're wondering, on that left side, nothing weighs more than 5 pounds. We have seen a couple robots actually fall, taking the concrete side as well as the rubble side. But so far, so good on the blue course.
NASA's saying that's the name of the robot, not the team that's
So we've seen some robots in this situation before where they have fallen. It'll be interesting to see. Now, robot's now officially been touched. Can't tell by the line there if it actually crossed the line. And we learned after yesterday's first round, Team MIT, their robot actually took a fall out of egress, but fell into the proper area, so that wasn't the prettiest dismount, but they still earned a point. It'll be interesting to see if the DARPA officials will allow for a point if it did indeed, in fact, completely cross that yellow line. As soon as we get the official word, we'll keep you posted on that. But let's move over to the red course right now. It's Team Trooper, earning 2 points thus far in the competition. Today, a successful drive and a successful egress. Now the door task lies ahead. Find the handle, rotate it, push it open, and then you have to cross through the doorway, that yellow line right at the floor, to earn that point. So over on the blue course, we did see from Team AIST NATO, their robot took a fall on the rubble. The good news is they did successfully cross the line, so they have earned that point. So 5 points in this round, coming off a 1-point performance yesterday, so a significant increase for the HRP2 Plus robot. Problem is at this point, they're running short on time. Because of the reset, they've lost 10 minutes, not enough time for the round, so the day is over on the blue course for them. Meanwhile, over on green, seeing a little bit more movement. Over on that green course, HRP2, Tokyo, looking like it's trying to earn another point, and it has. It's gotten through the door. Let's move along over to the red course right now. Team Trooper, good news for them. A successful drive for 1 point, a successful egress for 2, and potentially looking at a third. They've propped the door open. Now you have to find its way through that doorway. The robot is called Leo. It's one of those Atlas robots. In fact, 6 domestic teams are using the Atlas robot. 1 international team, that one hailing from Hong Kong. So there's some good news and bad news over on the red track. The good news is while the round is ending for yellow, green, and blue, Team Trooper was awarded an extra 5 minutes, but after this fall, and it looks like they're going to tether the robot, that'll be a 10-minute penalty, so it looks like that round would be over. All right. Once again, here's a look at the updated leaderboard, which you can find on your own phone. If you have an Android and iOS device, it's all good. DRC Finals app, you can download it. Real-time scoring for you. This is the most up-to-date standings that we have thus far. And as you can see, some significant strides for some teams that did struggle yesterday. Still everyone, though, looking at the top. This is truly one of the coolest demonstrations you're going to see. In fact, I had heard about this robot before I even got to the competition. Everyone kept telling me about the MIT Cheetah robot, and Sang Bei from MIT joins me on the set here. Another demonstration is about to take place on the track. It's great to have you here. I think one of the coolest things about your robot is not only just the way it looks, but the mobility and specifically that jumping ability. We don't often see that with an obstacle in front of a robot, able to figure it out in a running speed for the robot and still able to jump. How did you guys accomplish it?
Thank you so much. The first thing is that we had to develop our robot from scratch. I remember at some point we're winding coil of our motors because we had to design this robot specifically for this very dynamic behaviors. And then once you achieve this pretty fast running and this powerful motor working, now we start integrating this vision sensor. So we use this laser distance sensor to detect the obstacle, and now we can write an algorithm can jump over obstacle autonomously.
How long did the process take to build a robot like this, especially if you're doing it from scratch?
Yeah, it's a pretty tough process. We broke more than 200 legs. And then we rebuilt our robot more than 5 times. We redesigned the robot more than 5 times. We probably reassembled more than 100 times. And then we broke so many parts, so many hearts. And we changed our shoes more than 100 times as well. It's pretty harsh environment for robots. I think that's the way we should move toward, because we've been using our robots inside of the factories and lab, very controlled environment. In order to use a robot in the very unstructured and very dangerous environment, we need to build a robot very ruggedized and very dynamic and very powerful as well.
How does it handle the terrain? I mean, because at the end of the day, when you're talking about variances with hills or just the texture that the robot's running on, how do you make sure, you mentioned the shoes, it was something that we saw on display yesterday where there was a little bit of an issue because they were new shoes, but how do you manage problems like that?
So if you look at how humans do, humans actually use all 3 organs. We use our eyes, it's a very good processor, and then we use our vegetables in our ears, and we use our muscles. So in our robot, we only use ears and then our muscles. So we need to actually start improving our vision sensor. So that's what's lacking at this point. So once you get the better vision with the integrated, I think it's going to be as good as human. Yeah.
All right, let's take a closer look on the track right now and get an up-close and personal look at the MIT Cheetah robot. Take me through some of the things that we're going to be seeing here. You mentioned those shoes, and they're not exactly Nikes, but they are yellow out there.
Yes.
What's the significance of having to change them so often?
Because it has to be tough at the same time, very soft, but it cannot be too soft. Because if it's too soft, it's like you're running on your mattress. It's very hard to run on the bed or a mattress. So it has to be right stiffness, and at the same time, it should be very tough. It's pretty tough to design perfect shoes for the cheetah.
Functionality here, we're seeing sort of the trot. I've seen it sort of do that jump as well. What are some of the other movements that it can make?
We cannot show here, but we can actually do turning while running.
Wow.
The space is too small, so we're still working on it. So in the future, we can, the cheetah probably can turn in a very tight corner. Like you can see in one of those nature video, where real cheetah, turn in a dime in a 1 meter radius while running 35 miles per hour. That's pretty incredible. Yeah. So hopefully we can reach a portion of that in the future.
How fast is the MIT Cheetah?
We can run blind control without vision sensor up to 13 miles per hour.
Wow.
We believe that with a better vision sensor, this mechanically, this robot can reach up to 20 miles per hour.
You mentioned the turning, and to me that's interesting because you said the track, at least for right now, is a little bit too narrow. How wide are the turns for your robot?
So right now is about 5 meter radius, so it takes at least a 10 meter wide space to turn around. we hope that we can reduce that up to 2 meters in the future. Yeah.
One of the coolest things too, and it's something that I heard you say yesterday about the efficiency of this robot. Give me some perspective on just how efficient this robot is.
So this robot is probably the most efficient quadruped in the world. Currently is as efficient as a real animal. And for example, when this robot runs about 10 miles per hour, it consumes about 800 watts. If you think about microwave oven, which is about 1,000 watts, this is actually consuming less than your microwave oven and then can run at about 10 miles per hour.
How is it? It's running on batteries. How long can it run for, especially if it's that efficient?
So using current 3 kilogram battery, it can run about 1 hour at 10 miles per hour.
What's the range then? You're
operating? That's a 10 mile basically.
Wow,
yeah, you can run 10 miles with one charge.
So when you're running 10 miles on one charge, and let's just say you're really far, your operator is really far away from you, you said there's sort of a vision sensor. Do you have a monitor that shows you sort of the movements and what the AMIT cheetah is seeing?
Probably not 10 miles for now, but we would like to develop more technology.
Yeah.
We can stream video from the cheetah head, and we can be able to text to cheetah, or come back, pick up my lunch, and then come back, and then we'll be able to interpret that text message, and then you can come back with the GPS mode.
So I don't have any pets at home, but I feel like this one might be more my speed if I can text the MIT cheetah to run some errands for me. Well, congratulations. This is really one of the coolest robots, one of the coolest demonstrations we've seen over the course of yesterday. So once again, congratulations. And of course, there's a closer look. There's more demonstrations that are coming up throughout the course of the day, not only here on the infield track, but also at the expo as well. But round number 3, 4 tracks are going to be kicking up in just a little bit, but round 3 is in about 20 minutes, 25 minutes or so. As you take a closer look at the updated leaderboard, everyone's still looking at Chimp. That's the Tartan Rescue Team. Their robot, the only robot to complete all 8 tasks. Atreus is the name of the robot, and from Oregon State, Jonathan Hurst is with us here on the DARPA set. It's an impressive robot. We had an opportunity to speak yesterday about it. Let's just start with the name, Atreus. What does it stand for?
Atreus is an acronym. It stands for Assume the Robot is a Sphere, and that's a recognition of the philosophy behind the robot. The robot is based on some really simple mathematical models that are derived from biomechanics and from observations of animals' work.
We've seen some 2-legged robots, 4-legged robots. Yours happens to have two legs, and in my head, I'd say, hey, you know, the stability of a 4-legged robot might actually be better than 2 legs, and yet I've seen you guys throw dodgeballs at yours, kick the robot as well, and it seems to not affect the stability. Why is that?
Well, so the robot has an inertial measurement unit on it, so it has to actively balance all the time. And you might notice there's really not much in the way of feet on the robot. They're small little points, and so even standing, it's going to need to go step, 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 right, left, all the time. When you give it shoves, it always is calculating which way is up and then placing its feet to stay balanced. And that's you can't hide with 2 feet. You know, you really have to always stay balanced. If you get tripped up a little bit, you can't rely on the fact that there's 4 feet to sort of stop and get yourself stabilized again.
Does it have cameras on it?
The robot has no external sensors at all.
Wow.
So when it's walking over uneven terrain, bumps in the ground, natural terrain, things like that, it's just showing stability. I think the best way to identify with it is to imagine yourself in the robot's place. You're wearing a pair of stilts, first of all, because there's no feet to speak of. And then you're blind, and you have no arms, and your upper body is completely immobilized. And then someone pushes you around a little bit and walks you over rough terrain. You know, for the most part, you can do it. And I think the robot does pretty well in that scenario.
How efficient is Atreus?
Atreus has a cost of transport of 1. Now, that number is not very meaningful for most people. It takes about 600 watts. And for a robot that's about human scale and human speed, that's really not a lot of power.
Give me some perspective on 600 watts.
Well, I mean, how much is a toaster oven? 1,500 watts, so it's half of a toaster oven. We run on a battery pack that's about the size of a milk carton, the size and weight of a milk carton, and we can go between half an hour and an hour on that battery pack.
Why build Atreus? What was the game plan, the thought process behind building a robot like this?
So Atreus is really like I said, it's an implementation of a simple mathematical model. And this is a theory that, in simulation shows that we can do walking gaits and running gaits that really match what animals do, what humans do. And it can be incredibly efficient and incredibly robust. And so this robot was an experiment to say, if we implement that math model on a real machine, are we going to be able to replicate all of those behaviors that is the promise of the theory and what we think we can get with animals? And the answer is yes, it's working really well here.
What's next for Atreus?
So the next step for Atreus is, the next steps for Atreus may be, we learn what we can from this machine, but based on all that we've already learned about how to build the machine, about how to control the machine, it's time to start doing some good engineering and build a new robot every year and start improving it dramatically each time so that these can be actually and truly useful in the real world. Walking around and running in human environments, maybe search and rescue, expanding this knowledge and information out into prosthetic limbs or exoskeletons. It's that sort of thing. So what's important about Atreus is the knowledge and the science that we've gained by it.
All right, if I wanted to take a closer look, if they allow me to get off of the desk for a few minutes and I head to the expo, where can I see Atreus up close and personal?
Yeah, so we have a tent down at the expo area, and we'll be doing demonstrations throughout the day today. And we also have another Atreus up on a stand, so you can come and look under the covers. We have baseball cards to hand out with specs for the robot and things like that. We'd be happy to talk to you, answer any questions you may have.
Very cool. Jonathan, really appreciate you stopping by with us. Best of luck to you with Atreus, one of the cooler robots we've seen. I just like the fact that you can kick the machine and it just keeps on going. I do that at home and I usually break my stuff.
Do you kick your siblings?
No comments on that. I'm going to leave that one alone. But congratulations on the success that you've had with this robot. And back on the DARPA set, the demonstrations continue to unfold. In about 15 minutes time, all 4 tracks, though, will be in complete action. We'll get round number 3 started. But Helen Grainer from Sci-Fi is with us right now. And you guys are showcasing your drone. Give me an idea. I mean, I've heard drones. I've seen them used, especially athletic venues, different teams sometimes use them to shoot practice. And we've seen them sort of commercially as well. What makes your drone different than the other ones I've seen?
The POG system that we'll be flying today is very different. It's persistent. When you send it up, it stays up. And it does that through a microfilm tether. And the tether supplies power and communications for the robot system. It also gives you that proactive constraint, so it can't go anywhere. And that's why we have permission to fly today above the DARPA Robotics Challenge.
So we're going to be actually tracking one of the other robots that's out there, and hopefully we're going to be launching this drone. What is it, though? I mean, you're telling me about persistency, and how high up, though, can actually the drone go?
The POG vehicle could fly to 1,000 feet, which is really high. The FAA will restrict it to 500 feet. Today, we're only going to be flying to 100 feet because we have an airport close by.
How efficient is this drone? How long can it run for?
This robot, it really runs 24/7. We take it out and we fly it for days at a time.
Take me through what I'm seeing right now.
The POG has launched and it's in the air. It has a camera system on board, so we can get a bird's eye view of what's going on below. So you would launch this robot at a forward operating base for the military, a combat outpost, and it will be able to get situational awareness for the troops and keep them safe, because it'll always be looking at what's going on in the local area. It's also, we've had a lot of pull to get it into the commercial environment. You can put it above a mine or a construction site or on a farm or over a port, and you can see what's going on at that facility, not just for half an hour, but 24/7.
So the view that I'm looking at right now is actually the camera that's on your drone as it's following Spot.
Oh, look, the drones has seen Spot, which is a dynamic walking robot made by Boston Dynamics. That's really, really cool. And we're getting a bird's eye view of the Boston Dynamic a robot right now from the drone that you can see flying if you look just above the palm trees to the left of the DARPA Robotics Challenge.
So if you're in the grandstands, if you focus your attention to the yellow track and then continue to work your way out there, you'll see that drone that's flying just above the tree line and once again tracking. What's the remote for your drone? I mean, how is it being operated?
We do have people controlling the camera system today. To control the park system, to launch it, you set an altitude, you push one button, and it flies. So there's really no piloting required. The people are operating the camera system today, so they're following what Spot is doing on the ground. And we're going to automate that soon. So by looking at video analytics coming from the robot, we'll be able to follow the action on the ground. And so then we require no human operator and get just the information that people need about what's going on at their facility or their combat outpost or their port or whatever they want to see.
I think Sarah Kustoff, who's been roaming the expo and the sidelines as well, is actually a field level right now.
So you can see we're getting a whole new perspective from the drone. Most of the video you've seen has come from the side. This is getting a bird's eye view of what's going on down below, and it's following the Boston Dynamics Spot vehicle, which is a very, very cool new robot from Boston Dynamics.
And the life of the drone, I mean, how long can it be up in the air for?
This drone is designed for 24/7 operation.
Wow.
We've run it for days at a time. It's being powered from the ground with this very, very long microfilament, which you really can't see with the naked eye. And that filament is providing power, and it's providing communications. It's transmitting the video signal down from the drone so it can't be hacked or spoofed or intercepted. And it's also providing this proactive constraint for the vehicle.
Well, it's certainly incredible technology. Were you going to add something?
Oh, I was just going to add that if you want to learn more, we're in booth 65. We've also got some other free-flying drones, which they will only let us fly in the aviary because they're not tethered like the park system. And we'll be doing demos throughout the afternoon in the unmanned air vehicle aviary of this another really cool drone that we have, and we hope you'll come over, check that out. It's called the Sci-Fi Level 1, and we have a Kickstarter campaign going for it right now, and getting it, we call it the drone for everyone, so everyone now can have a drone that flies really, really well.
Looking forward to seeing that once again over at the expo. Helen, appreciate you showcasing your drone for us.
Thank you so much. We're so happy to be here and get that bird's eye view of the DARPA Robotics Challenge.
And once again, the demonstrations continue to unfold here throughout the course of the day over at the expo, and we'll continue to do some more demonstrations for you here at the grandstand, on the track, or even on the field. Welcome back to the DARPA Robotics Challenge. It's the finals of 2015, day number 2, round number 3. Some information to update you on. Once again, if you're looking for the most up-to-date standings, all you have to do is download the app on your phone. It's the DRC Finals app, and right off the start on the blue track, we have immediate action. Team Robotis. Thormang is the name of its robot, and cruising during the drive task so far. Team Robotis yesterday on the blue track that you're watching right now, they did score a pretty fast time on the drive, so not shocking that on another run, and there's the point, crossing that checkered line. Team Robotis did earn 2 points yesterday. They pick up 1 in the early goings here. check back in on blue in just a moment. Just a quick update for you as well over on the red track. A little bit of a delay. It'll be about just a few minutes before they get underway. But let's shift our attention now to green. Jackson is the name of the robot team. Nadu JSK. They scored 2 points in the competition yesterday as well. Able to complete the drive task and the door task. As you can see over on blue right now, blue team, Team Robotis, is going to punt on the egress, which is the second task of the competition. That's trying to see if the robot can get out of the vehicle all by itself. All these robots driving a Polaris Ranger XP900 is, once again, you're taking a closer look at NATO JSK. Jackson, the robot, picks up his first point. Let's take it to the yellow track. Team Walkman earned 2 points after the first day of competition, trying to make its move during the drive task. Team Walkman picking up its first point on day number 2. So after just picking up a point on the green track, you can see a lot of the team representative going out there, trying to tether the robot. Not uncommon, something we saw on day number 1. Not every one of these robots is capable of getting out of the vehicles themselves, so they will punt on that point. Remember, 8 total tasks, and just about 1 hour to complete all 8, or as many as you can during the course of the 60 minutes. When you do tether your robot, it's considered a reset, and at that point it is a 10-minute penalty. And over on the yellow track, we just showed you Team Walkman picking up its first point on the drive, but the team representatives once again coming out, ready to tether the robot and set up for the third task, which would be door. Let's take a closer look at Team Walkman.
My name is Nikos Sagarakis, and I'm in Team Walkman. We're about 25 people. It's actually a collaboration between the Italian Institute of Technology in Genova and also University of Pisa in Italy. As a team, we had to develop our own hardware. This means that we have a number of people that work actually on the design, on the hardware, on the electronics of the robot. Then the rest of the people are mostly working on the motion control of the platform and actually on the development of the software for the high level, executing the tasks of the DRC. For us, as we actually use a humanoid robot, which is basically has 2 legs and it has to balance in 2 legs, this is a big challenge for any platform as a humanoid form. DRC was a very good opportunity for us to develop, actually evaluate our system, but also to accelerate the development of the system. And we hope that we are going to have something that will work very well also in a scenario that will be even more realistic in 3 years from now. A good advantage for us is actually that we develop our platform, means that we know everything about it, and we can actually perform full debug and maintenance at any time that can help us to solve problems faster, I would say. Have an electrical system that actually, compared to other systems, maybe have some better efficiency. So we hope that it will give us also a certain advantage for the finals.
All right, once again, a closer look at what's transpiring on the yellow track right now as we got a closer look at Team Walkman. All 3 teams that are in action right now, all looking at a reset, 10-minute penalty for all 3 teams as we take you to the blue course. Thormang the robot. From Team Robotics. It's a South Korean team as we take a closer look at the squad.
My name is J.K. Han. I'm representative of Team Robotics. Robotics is a Korean team, South Korea, and we consist of Korea Tech University and Korea Robot Society. So we are a strong and solid team. Our robot is very unique because it's modular robot. So we are developing the modular sub-actuator, and the robot is just connecting that modular sub-actuators. It's very easy to build it. That's why many teams are using our robots in this competition. In DRC finals, 4 teams are using our robot platform, and 2 other teams are using our servo actuators named Dynamics Pro. The name of our robot is Thormang. Thormang are used by Team Thor, Team SNU, Team Hector, and the Team VALOR and Team Nimbro are using our servo actuators. It's a competition, but the more important thing is improving the technology. To improve the technology, we need help each other. So we are sharing the information and ideas. Driving a car is very challenging. We are having a discussion every day how to drive a car and how to get out from the car, things like that. This is very fun discussion. Also, get through some uneven terrain is quite a difficult task. It is very challenging. It makes us very exciting. I'm very proud I'm involved in this event. Robotics is kind of a small corporation, but we have a dream to contribute to the world. Korean kids are very, very excited about this. I hope they have a dream because of our team.
회전이 돼갖고 그런 것 같아.
The result is a second thing. The most important thing is we enjoy this competition and we are developing the technology very fast due to the competition. After the finals, we have a big plan to collaborate all robot society. We will have a lot of experience here and we need to share our experience.
Well, a closer look at Team Robotics on the blue track. Get a feel of the mindset of this team. Thormang is the name of their robot, successfully completing the drive. Team decided to go on a reset on the egress portion of the task, which is getting out of the vehicle, and now looking at the door task. We'll check back in on Thormang in just a few moments. Meanwhile, over on green, Jackson also completing the drive. Now eyeing down the door task, and as they get set to untether Jackson. Let's take a closer look at NATO JSK.
My name is Masayuki Naba. I represent the team NATO JSK. We are building a new robot named Jackson, which is designed more human-like. They are now in Japan in our lab. They are still working with the new hardware. And now we are testing the software part. We have developed a software who try to solve everything autonomously. But in this challenge, we try to add the human interaction, teleoperated. But trial, the human controlled everything, human and robot interaction design is very important in this challenge. So this is very nice research platform. Right now we are developing that getting off action from the car to the ground. That is my current concern. We have developed humanoid performance, especially in the inside, like a living room assistant, human assistants so far. But after DLC announcement, we are trying to apply our technology for the field applications. For the outside field, we are starting the agriculture application. In Japan, we believe that robotics is very important.
All right, so the team bio for Jackson's squad over on the green track as they get ready for the door portion. No, there's some oohs and ahs over because of the action on the blue track as we take a closer look there. Thormang actually successfully opened the door, didn't earn that point, instead caught itself on the fall, but wasn't able to keep its balance. So you're looking at another 10-minute penalty as they reset. If you're wondering what's happening on red, Team Vicker has been granted a 20-minute delay. Let's take you back to green right now, where Team NATO JSK, their robot is called Jackson, trying to make its way towards that door handle. Remember, not just opening the door, but crossing that yellow tape in the door frame. That will earn you the point.
There you go. Don't tell Daddy you took it off that easily.
You can be a Mets fan. You can sit right up here.
Yeah, climb up. Let me take a picture.
What was her name?
Audrey.
Audrey. Did you beat Sarah?
No, she didn't.
So you should beat Sarah because here we are against Sarah's other child. Yes, no. Her name is so she does Nets. She does basketball.
You know how Daddy always has the TV on the Yes Network to watch the games?
So you gotta hold it like absolutely.
There we go. Yeah. Mike's the guy that's telling everyone in the crowd what's happening. How's he going? Oh, they're on the way. Oh.
So the team from Tokyo, Japan, on the green track, that robot is called Jackson. 20 years of research and humanoid robot experience, both in software and hardware for NATO JSK, and they've earned another point in the competition. Make it now 2 total points after the third task. Did the drive successfully, punted on egress, got through the door. Sort of an interesting development here after day number 1, we saw some teams go out of order in the tasks. Typically from door you go to valve to wall to surprise, then to rubble, and then stairs. But some of these robots have decided to go out of order, so it'll be interesting to see, although it does look like Jackson's lining up to approach the valve. Good news on the yellow course for Team Walkman. Able to push that door open. Once again, you earn the point as soon as you get through the doorway and cross that yellow line on the floor. So just in case you were wondering, we did see on the blue track Thormay take that spill. This has happened yesterday, and the DARPA officials have allowed the scoring to take place this way. So even though there was a fall and a reset, they still will be penalized. Yellow's creep. We'll find out if Yellow's on the yellow course able to stay up. Team Walkman just able to rally itself. Meanwhile, over on red, there was a little bit of a delay. Not a penalty delay, just a regular delay on the red course for Team Vigor, and they are off to the races, moving down the driving task. As I was referencing before on the blue track, Thormang actually fell through the doorway, and we do have a fall over on yellow. So we'll find out if Team Walkman will take the reset, or if the Walkman robot will be able to get up on its own power. In fact, after yesterday, just one robot was able to accomplish that, but Team Vigor right now certainly on the move. So the point I was trying to make on blue, DARPA officials have awarded Thormang a point. Even though it fell, it did clear the door frame and got past that yellow line, so they did pick up that second point. I'll head over to green. We speculated where Jackson was going to go, as some of the robots have decided to Jackson is working on that valve, got to spin it 360 degrees. Meanwhile, on red, just veering off course, but you can see the steering wheel turn. It looks like they'll be able to make the correction in the Polaris Ranger XP 900. So over on the red track, after a 20-minute delay, Team Vigor was cruising down the drive task, but you can see the team representatives going to fix whatever issue they are having, so that'll count as a team reset, a 10-minute penalty for them. While over on the green course, Jackson is trying to turn the valve 360 degrees. If you're looking for a marking point, look at the top of that valve, there's a black piece of tape, so 360 degrees, a full revolution is what they have to do. I know many of you guys are watching us on the monitors in the grandstands, but over at the expo, the University of Pennsylvania's GRASP lab is going to be demonstrating a formation flight with the swarm of multiple unmanned aircrafts. It's going to happen top of the hour at noon over by the unmanned aerial vehicles area. So green earning the point on the valve task. So Jackson the robot now with three total points. One for the drive, one for the door, now one for the valve. Over on blue, Thormag earned the point for getting through the door. They did take the reset, so that's 2 resets, a 20-minute total penalty now for Team Robotis. Over on the red course, that was a reset, so they'll try the drive task once again. Meanwhile, over on yellow, Team Walkman, after that fall, resetting to try to get through the doorway. So another point scored for the blue team. We'll transition ourselves over to green as they make their way to the wall task. We've seen this happen before where some robots have decided, and teams rather, I should say, have decided to skip and move around the different tasks. One of the tasks that seemed to be a common skip, at least in the early portion of the round, was the wall task because of the precision that it requires. Remember, there's degraded communication, which essentially means when the robots are on the outside, so the tasks such as stairs to end the competition, the drive which starts egress and trying to get through the door, the teams that are in their garages that are manning the robots have a free path. It's completely clear. There's no issues with the communication. Once the robot actually gets through that doorway, DARPA has decided to degrade the communication. So think about it in these terms. Imagine you're in a club and it's black and there's a strobe light that just flashes. So in the early portion of the hour, the teams are only getting just 1 frame, 1 second of information. And the best robots are the ones that are able to handle their autonomy and take a general instruction. So for example, on the green track, as you watch Jackson, the image that the team is getting is not exactly what we're all seeing with the drill and the wall. What we are seeing, though, potentially is just a virtual map, so to speak, of the actual course. But as the hour progresses and we get a little bit closer to that point, the images do become more clear for the teams in the garage, and the communication with their robot becomes a little bit easier. Saw the reset on red, Team Vigor. Mentioned those garages. We'll take a closer look at what they're dealing with right now. After that reset, they had a 20-minute delay. That was no penalty, just a straight-up delay for them. They had a problem during the drive, so they have taken the reset and now are trying to work their way down the course. So as you can see here, as you take a look at what the team is actually looking at, the image completely clear, seeing through the eyes of Team Vigor. Now, once assuming that Florian, which is the name of their robot, is able to complete the drive, the egress, and get through the door, that image will not be nearly as clear. Over on yellow right now, rough news for Team Walkman. They are officially retiring from the competition. As you watch Team Vigor on the red track, this is the point where they had an issue on their initial run. Florian just sort of took a hard right turn, so we'll see if the team is able to correct whatever issue they had and earn that first point. Let's move to the blue course. Thormang from Team Robotics just finished the valve portion of the competition. Team Vigor on red, creeping closer to that checkered line to earn that first point. Remember, all 4 tires have to cross. Team Vigor wanting to make sure everyone knows that they earned that point. So Florian with the lattice first point of the competition. And over on green, Jackson having some issues on that wall task, falling backwards. based off of the history of what we've seen, and that's exactly where I was going, they will have to take a reset. That will be the second reset for Team Green. That's a total of 20 minutes as we take you back to blue. We saw Jackson on green trying to complete the wall task. Thormeng, meanwhile, on the blue track, opting, it looks as if it's going to skip that task and head over to the surprise. Over the course of the last 3 days, that surprise task has been different. On the rehearsal day, Thursday, it was a push button. Yesterday it was a pull switch, and then today it's actually pull a plug and then replug in. You can see 2 outlets that are there. We saw Team Vigor earn that first point in emphatic fashion. They are now taking yet another reset. That is their second reset of the competition. They've now been docked 20 total minutes. As we watch Thormeng make its way towards the surprise task, just a reminder to everyone, over at the Expo in about 10 minutes, Vicon excited to partner with Clear Path Robotics and Ascending Technologies to demonstrate precision quad-rotor flight in the unmanned area vehicles tent in that Expo today. Once again, it's coming up in about 10 minutes time. We'll shift our attention over to the red course right now. Team Vigor going for the reset with its robot Florian. Here's a closer look at what makes up Team Vigor.
My name is Stefan Kohlbrecher from TU Darmstadt in Germany. I'm with Team Vigor, and our robot name is Florian. A unique point about us is certainly that we span 9 time zones. So we have a lot of expertise from different people from around the world, from Germany, from the US, different groups, and everybody's working in their field of expertise to really get the robot doing all the stuff we want to do here. Yeah, we are very interested in helping people around the world because disaster can strike everywhere, and that's basically why we do it, and why we also have an international team, of course. Robotics are important for disaster relief because robots can do some things that humans cannot do. They can go into harm's way they can resist radiation where humans would die. So that's very important to have this capability in case the need arises. Of course, the capabilities we develop are also highly relevant for other tasks, basically. I mean, if you can turn a valve in a disaster scenario, you can also help in a whole household. So it's very much something that is widely useful beyond disaster response also. I think the toughest task is the driving task, because our robot is very strong and very big, and it's just very hard to do this, and especially to get out of the car. I think we will win because we are a very diverse team with a lot of different expertises from, like I said, different countries. So I think we have experts for all the tasks at hand, and that's why I think we will do very good at the competition.
So we'll check back in on Team Vigor in just a few moments, but we'll shift our attention to the blue track right now, where Thormang from Team Robotics working on the surprise task. Looks like it's grasped onto that plug. Got to pull the plug, and then you can see the second outlet there. Have to insert the plug onto the second outlet to earn the point. Here's a look at the garage, the team garage for Team Robotics, and what they're actually looking at. As you can see, Thormang actually is wobbly. Something tells me a team reset is sort of just understood at this point for the blue track. And it might go beyond just a team reset.
I'll let you know. Yeah. I'll let you know if it comes to that.
We'll focus our attention now over to the green track. Jackson coming off that reset, making its way through the door. Had already earned the point for the door after the fall. Take you back to the red course, Team Vigor. Florian is the robot. After 2 resets, has now opened the door, trying to earn that point. Got to walk through it though and cross the yellow tape at the floor. So it looks like on the red track, it'll be a 3rd reset for Team Vigor after that fall. Let's take it to the green course right now, where Jackson got through that door. It looks like it's trying to earn a point maybe for stairs. It seems like it's bypassed all the tasks. After rubble, it is stairs. That's the final one. So over on the green track right now, Jackson has bypassed a slew of tasks, eyeing down stairs to try to earn a final point. Meanwhile, on the blue track, Thormang might win the award for most courageous team after losing its head, literally, reattaching outside the door, and once again on the move inside. In about 5 minutes over in the responder demo area in the expo, another demonstration. Emergency responders, they put on a special protective equipment during hazardous material response to make really safe entry in some dangerous situations. Robots right now are allowing new potential means to gather data quickly and assess that situation. So if you stop by that demo area in about 5 minutes, you'll be able to see the special protective equipment responders are going to be wearing and how robots are proving themselves beneficial for hazardous material response. So Jackson making it to the top of the stairs. I believe, if my memory serves me correct, he is just either the 4th or the 5th robot in the competition so far to reach the top of the stairs. So another point for Jackson. Latest, most up-to-date totals, you can get them right on your phone. You can download the DRC Finals app.
I agree.
So NATO JSK, 4 points. Yesterday, they scored 3. So after a successful drive, the door task, the valve, and now the stairs, that is 4 points in 58 minutes and 39 seconds. So to keep you updated on what's happening on all these tracks, time at this point officially is running low, but keep in mind, Team Vigor, off of this reset, they'll get 20 extra minutes. They started a little bit behind, so they'll have a little extra time. We continue to talk about the importance of this competition and really what it could mean potentially moving forward in disaster relief. Here's a closer look at that.
My
name is Sven Demke. I'm heading the team Nimbro Rescue of University of Bonn, Germany.
我嘅名字係叫洪天偉，我代表香港大學。
Mein Name ist Stefan Kohlbrecher von der Technischen Universität Darmstadt.
We've got 25 teams from all over the world. There's teams from Japan, Korea, from Europe that have been doing fantastic work in humanoid robotics in particular, but in disaster response robots for a long time.
I think that disasters are a very human problem. Both injury and loss of life is a terrible emotional burden for any human being to have to bear for their loved ones. And so I think the whole world, regardless of politics or any sort of other struggles that we have, understands that disasters are just terrible things and appreciates the need to try to be able to be more robust to them and to respond to them.
Humanitarian assistance and disaster response is one of the primary missions for the Department of Defense and our United States military. In support of our national security strategy, we need to be postured globally to provide immediate response to any foreign nation. Here in the homeland, that's one of our primary responsibilities, is to stand ready to respond, be it enemy attack or any natural disaster. Any immediate response we can do overseas demonstrates our commitment to human life and preserving and supporting other countries.
Anything that's going to help get communities devastated because of a disaster quickly back to their feet, isn't that a call to everybody, regardless of, color, creed, nation? So to see that there is a global participation shows an awareness, and that's something, we really applaud.
Number one concern is human life. I mean, this type of technology and any operations in humanitarian assistance, disaster response, is to save lives. But there's second and third order benefits from this, increasing the capacity and capability of that foreign nation to take care of themselves. Regional stability just through HADR operations. And then global relationships for the United States. In the event that we have a catastrophic event, we're going to hope that that nation will come in and support us also.
Had there been a robot that could have been brought on site during the first few hours of the Fukushima disaster, it could have avoided contamination over a wide area that occurred after the explosions at Fukushima that generated an exclusion zone where still people can't move back to. If robots had been there, they could have opened valves to vent the reactors and to prevent those kinds of explosions.
We, as robot scientists, we go to conferences, we present papers, we collaborate. And these are people that we see at conferences. So it's very interesting to work with them again at a competition. And again, we're also working together to save humanity together. And that's why it's important to collaborate internationally as well.
I think the teams are motivated by several things. And most important, I think, is the problem that they're trying to solve to begin with. They really are trying to make the human condition much better, trying to make the world a safer place to be and lower the incredibly strong emotional burden of what happens when human beings are hurt or killed in disasters. No one deserves for that to happen to them. And so, can't we build systems that make that much less likely to occur?
On most of your Jumbotron screens, you're going to see the updated standings while Team Vigor continues to work. Remember, team started about 20 minutes late, so still have a little less than that at this point to continue to work and try to get through that door as they finish once again another reset. But as you take a closer look at those standings, some of those top teams based off of yesterday's performances, like Tartan Rescue, Chimp became a crowd favorite, only robot to successfully fall and get up on its own power and complete all 8 tasks for those 8 points. Be in action a little bit later in round number 6. Team Nimbro Rescue, easily the fastest robot that we saw. As you can see, 7 points in 34 minutes. And Team MIT picking up 6 points yesterday, went back to DARPA officials, thought they deserved an extra point on their egress after a fall. DARPA officials decided that they did in fact deserve that extra point. Once again, conclusion of round 3 coming up in just a couple minutes as Team Vigor continues to try to make its way through that door. Round 4 in about 45-50 minutes.
Right. I made sure the wind was going the right way. Should be no smell of chunk.
It's right. Seaplane's crashed. I would imagine she's still a real around. Oh, the VPN crashed. Well, this is right.
So the only robot in action right now is Florian from Team Vigor. About 12 more minutes to work. Remember, it started 20 minutes after all the other robots, so still eating into that clock. Over at the Expo right now, Sandia National Labs actually presenting the Urban Hopper. It's a mobile platform that can jump over obstacles over 40 times its own size. Make sure you head over to the unmanned area vehicles tent in the Expo. That's coming up at 12:45. So it's about 10 minutes away. So Florian from Team Vigor, we can confirm they've earned that point even with the fall because they were able to clear that yellow tape. Based off of time, we're thinking that the round is done. Nothing official just yet, but they had about 12 minutes. Now with the 10-minute penalty, it's going to be cutting it kind of close. With that in mind, we head back over to the expo. Sarah standing by with more.
Here at the Unmanned Aerial Vehicles demonstration area, joined by Steve Berger. And Steve, you're going to show us a mechanism called the Urban Hopper. Just describe to us the idea behind this.
Sure. So this is a small robotic system, a small ground system that's designed to travel on the ground and drive when it can. But the problem with small ground vehicles is when they encounter obstacles, they can't overcome them if they're very big relative to the vehicle. So here we overcome that by introducing a second way of moving, which is to hop. So we have a combustion-powered system that shoots it up in the air.
Why don't we take a look? We're going to have you turn around and start to operate this and take a look and see exactly how the Urban Hopper operates.
Sure. So basically, in one mode, we can drive, and that's what we're doing now. So we drive around on the ground and gain access. This is a small vehicle, about 8 pounds, about the size of a shoebox, so it easily fits in someone's backpack. But in the real world, little vehicles like this can't deal with large obstacles more than a few inches. So then if we have to get up in the air, we have to go over it. And so that's basically what we do here. So we tell it to hop, and we tell it how high to hop, and we tell it to go. So it's going through a sequence where it prepares, and then it fuels the fuel and the oxidizer, and then when it's ready, it fires. Now the hard thing about hopping, the first hop's always fine, but you have to survive that. So the second hop is always the hard one. So we'll see if we can do another one. So we can still drive, so that's good. And why don't we hop again? It looks like we're having communications problems. It's a small vehicle with a small radio. We'll bring it back closer. There's a lot of radios in this place today, a lot of robots.
That is the truth. And Steve, I would assume it could land on either side of the vehicle?
That's right. So it lands either way, then it recognizes which way is up, and I can drive it as forward and back, right and left, regardless of which side it's sitting on. So we'll try this one more time and see if we can get another hop. So here we go. The sequence is beginning. Oop. We lost communications again.
Nonetheless, very cool to see. Well, what's just the purpose and idea behind this?
So the idea is basically to have something that can be energy efficient in driving on the ground. So this thing can drive for about an hour, say, but then be able to deal with large obstacles. So small aerial vehicles are great, and they can get over things, but they typically can't fly for more than maybe 10 minutes or so. So here we get kind of a combination of long life and the ability to go up and over when we need to.
Awesome. Well, Steve, we certainly appreciate your time and the Urban Hopper. Fun to watch.
Thank you.
All right, we're going to send it back out to the track. And again, don't forget, fans, to come out and take a look at so many of these interesting robots and robotics we have out here on the expo.
It is day 2 of the DARPA Robotics Challenge. It's the finals of 2015. Day 1 provided drama we have never seen before. Crowd favorites have emerged. Underdogs have become Cinderellas, and we are just hours away from awarding $2 million to the winner, and more importantly, potentially revolutionizing how we handle man-made and natural disasters. And with that, I'm Mike Am. Here on the DARPA set, Sarah Kustoff will be joining us momentarily with reports, obviously, from the track, not to mention what's happening out in the expo. But there are 4 tracks behind me. We are going to be entering phase round number 4 on day number 2. Some of the top teams that we saw yesterday will get an opportunity to showcase some of their skills. But really the importance of this competition, it's significant. It's potentially how we're going to handle natural disasters moving forward. And with that in mind, this competition, we've created sort of a fake scenario for these robots to try to execute.
We have breaking news. A 7.3 earthquake has struck Central. Hundreds of reports are coming in now from frazzled residents who are witnessing major structural damage. The governor has declared a state of emergency, and he's asking the president to send help as quickly as possible. Let's go out to our reporter on the spot who's monitoring some of the damage.
Right now, officials are saying the extent of the damage at the facility is significant. The California Power Safety Agency has now evacuated the facility. Fortunately, no one has been significantly injured, but no humans will be allowed back into the plant to contain the blaze. Officials say the next step is to send in the emergency response robot teams. First, these robots will need to drive a response vehicle to the scene, not knowing exactly what they might encounter. Once there, they will then have to enter the plant, locate the fire control system, and turn the main water valve to begin fire suppression. The challenges that await these robots could be navigating debris from the earthquake, cutting through walls to gain access, climbing dangerous stairs, and even some unknown conditions. Let's go live now to the plant where the robot teams are beginning to deploy.
Well, let's take you through the updated leaderboard, and once again, action in round number 4 underway, but certainly some impressive performances that we did get to see. Everyone seemed to like that Tartan Rescue Squad. Chimp, the robot, was certainly very popular. We'll see him in a couple rounds, round number 6, but let's get you some action right now, and we'll start on the yellow track. It's one of the robots that we didn't get too much time to see yesterday from Track Labs. Hercules running on with an Atlas robot. On finish with 5 points in about 49 minutes on day number 1, which was yesterday, but off to the races right now in this driving task. What you're going to see if you've been with us all day, some differences compared to the earlier rounds. In those earlier rounds, many of the robots didn't even drive. Of course, they forego that point. But the rest of the way, all the robots that are still alive for potentially in the best position to win that $2 million prize, all have been able to drive. The best one's also able to egress, which is what happens after they finish the driving portion, trying to get out of the car by itself. But once again, it's Hercules from Track Labs. It's based in Houston, Texas. And once you cross that checkered line, like Hercules has done, you earn yourself a point. One of the interesting differences here when you look at that yellow track with Hercules, many of the robots actually have been getting out on the passenger side of the car. In this particular instance, Hercules actually set up on the driver's side. And I see representatives of the teams heading out there. If Hercules cannot, and it doesn't look like he's going to be able to get out of the car on his own power, that means that Team Track Labs will forego the egress point. And with the reset here, that also will cost him 10 minutes. Moving our attention now to the green track. Team Thor also making its move. Earned 3 points yesterday. Collaborative effort in terms of the makeup of this team. Students, engineers, professors from University of Pennsylvania, from the Pac-12 Conference, UCLA. Let's focus our attention now on the blue track, and I actually had my tracks confused there. Over on yellow, it's actually Team SNU. Over on blue, it's from Track Labs. That is Hercules running that Atlas robot. we'll switch our attention now to the green track. Team Thor once again making its way down the driving section of the course. Sarah Kustov standing by with team representatives.
Lee, and we got some cheers for the crowd for Thor as it continues to move. Daniel, how would you just describe the progress so far by your robot?
Of course, we're very happy of how it's going. Hopefully we'll get this point pretty soon, and then we're going to head inside the building and try to get some more points in there today.
Daniel, yesterday you guys did the drive, the door, the valve. What did you learn from that experience and just the adjustments that you tried to make last night as you headed into today?
Sure, that was kind of our first time we strung together a whole bunch of tasks. I know as we were preparing you, we kind of focus on the individual task, but this event is really about trying to do that consistently in a sequential fashion. And so we're hoping to kind of replicate that and maybe add a couple of additional tasks.
Of course, plenty of practice, both on the rehearsal day and just in these past years, but what's been the biggest challenge as you now have faced and finally gotten here into the finals?
I think the biggest challenge is, we're coming together as a team. We have 2 different universities. We're trying to learn each other as we're doing this, and everyone's having a good time so far.
What's the hope for today in getting past maybe some of the tasks that you did yesterday?
Well, yesterday we did it very slow and steady, so we're trying to go a little faster today, improve our times, and then hopefully add this surprise task if we can do it at the end.
All right, Daniel, we don't want to hold you up. We'll let you keep going, but thank you so much for your time and good luck as you continue.
Thank you, Sarah.
All right, Mike, back to you.
All right, Sarah, so once again on the green track, it's Team Thor. They'll take the 10-minute penalty for going the egress section of the task. Transition back to the blue course, Team Track Labs. It is Hercules. Once again, riding that using the Atlas robot. Yesterday in the opening round, the team from Track Labs, which is this Hercules robot, they earned 5 points in 49 minutes. Sort of put them in the middle of the pack in terms of the standings.
Looks like somebody else was in that slot at that time. Are they moving? No, that was Baker. So just let me bring them something. So that means that DRC Hugo will no longer be in that yellow slot at 5:15. Hang on a second.
not the start that Track Labs is hoping for over on the blue course. You can see they're taking a reset. They'll bring the Polaris Ranger XP900. That's the vehicle that all the robots are expected to drive. They'll bring that back down to the starting point. In the process, we'll take a closer look at this team that's based in Texas.
My name is Rob Burridge. I represent Team Track Labs. Our robot is an Atlas named Hercules. When I was a kid and Star Wars came out as a movie, we had a movie where the robots were the good guys and good characters and really charismatic, and I think every kid wanted to be able to develop robots that acted like R2-D2 and C-3PO. At Track Labs, we've been developing software for robots for 20 years now, and one of the things that makes Track Labs development unique is that we have a very small team, so that if somebody gets a good idea, they can try it out right away. And so within a day or two, they could be trying their new idea on the robot. We have our software is actually a fairly small footprint. We're using the Boston Dynamics behaviors. For the earlier versions of this competition, our software really focused on human in the loop, where the human was very much part of the decision-making process for the activity of the robot. As we get on towards the finals, we're pushing more autonomy over to the robot side. We're very interested in how the human and the robot can work together as a team to accomplish these goals. Another thing that's been really important in the past year is we've developed some strong collaboration with other teams, IHMC and MIT, and we're sharing software, and so the teams are coming together as a community much more now than they were before the trials. I think everyone I know is always asking me, so what's new? What is your robot doing today? What has he done? What new tasks is he accomplishing today? It's always fun to show them pictures and video of the latest. I think we're all winners in this competition because we're all developing, and the whole community is going to gain from the stuff developed by all of these teams together.
All right, let's take a closer look at what's happening on the yellow track. Team SNU, we saw them drive successfully to earn their 1 point. Needed a team reset, which will cost them 10 minutes. And in the process, they do not earn the point of the egress, which is the robot getting out of the vehicle. So now it is the third task of the competition, which is getting through the door. It's not just opening the door to earn the point. You'll need to obviously swing the door open and then walk through. You'll see some yellow tape there at the bottom of the doorway. Once the robot crosses over that plane, they'll pick up that point. So over on the yellow track right now, Team SNU just getting the wobble going and able to regain its balance. Remember, just because the door is open doesn't mean the team has earned a point. Just 1 point has been earned right now on that yellow track. It comes from the drive. 10-minute penalty on the reset and foregoing the point on egress, but and it looks like Thormang might need another reset there. So we'll go from yellow to green right now, where Team Thor is trying to move just past the point that we just saw on the yellow track. Got the door open, needs to cross that plane. So Team Thor officially earning that point. Make it now 2 points, and if you want to follow the standings in real time, all you have to do is download the DRC Finals app. Some social media opportunities on there if you want to take some pictures, status updates, the full schedule of what's happening over at the Expo. All part of that DRC Finals app, available for Android and iOS devices. taking a closer look on that Jumbotron in the middle of the field at the green track specifically. That's Team Thor. They earned 3 points yesterday after the first round. Now keep in mind, what makes this competition hard is not just doing the task, it's what happens once they get through that door. Communication between the team garage and the robot themselves during the drive, egress, and getting to the door is perfectly normal. Once they complete the door task, there's a degraded communication that takes place. Easiest way for me to describe that to you is like as if you're being on a cell phone and not hearing the other person, just hear sporadic words, or if you're in a club and it's dark and it's one strobe light. So over the course of 30 seconds or so, these robots are only transmitting just one bit of information, one piece of information to the team garage. The best robots are the ones that handle the autonomy the best and are able to create a visual map and then execute commands. But we'll have a little bit more on Team Thor. Sarah's standing by.
Thank you, Mike. Yeah, once again with Dr. Daniel Lee, and we heard Mike talk about communications with Team Garage. If you could just expand upon the work that they're doing and just how they do try and communicate with your representatives here in the field.
Sure. At this time, once you go through the doorway, the communication is very degraded. So it's a very stressful time for our students to try to operate and monitor what the robot is doing with kind of limited feedback coming from the robot.
Are there things from yesterday that you learn about how the robot adapted to that you can apply to today?
Yeah, we learned a lot yesterday. They had some experience in trying to see exactly where the robot should be positioned relative to the valve right now. And so they're trying to figure out what's the most efficient way of trying to get the hand in place to rotate the valve.
Now, you guys did earn the point on the valve task yesterday. Where do you feel about the progress you're at to this point, getting to the valve, and just what you're hoping to do as you continue on?
Yeah, we're very happy because we've done it a lot faster today, and that's the whole point of this, is to try to improve every time you do the course.
And just more specifically, Daniel, on the valve, walk us through what the robot is doing, potentially thinking, and just how it's trying to actually execute this task at the moment.
Sure. The main thing here is to center the robot hand with the wheel of the valve so that when you go in and use your prongs, that you'll get a nice kind of rotation on the valve.
What is it about the structure of your robot and just why you chose to develop in the ways that you did that allow it to be successful on a task like this one?
Well, we feel like our robot's very general purpose. For this task, we are just using basically 2 sticks on a hand to kind of manipulate the valve and in the same way we do the steering on the car.
All right, Daniel, I appreciate your time again as we watch the valve hopefully be turned. Good luck as you guys continue on.
Thank you very much.
All right, Mac, back to you.
All right, Sarah, as you mentioned, for this Team Thor right now trying to execute a completion of the valve task. Fairly straightforward here, just have to turn the valve 360 degrees. Just heard from Dr. Lee why it's so difficult at this stage of the competition. If you're looking for that marker, every single one of the valves has that piece of black tape at the top, 360, just need one full revolution through. So Thor just showing off with a little extra revolution there, but they have officially earned that point. It's now 3 points for them. Already heard from one representative from Team Thor. Here's a closer look at the entire squad.
My name is Stephen McGill. I represent the University of Pennsylvania and Team Thor.
My name is Dennis Hong. I represent UCLA Team Thor. And our robot name is Thor OP. For the trials, we actually developed two robots. One robot is called Thor, the other one is called Thor OP. For the trials, the Thor OP was very successful, so we passed the trials and we're here at the finals. However, we decided to split the team.
When you have two robots on one team, it makes it easier to experiment. So in case you break something, you know that your partner university will have a backup motor just in case something happens. UCLA will work on many of the mechanical things, and they also do a lot in the software. And we try to do a lot on the software end at the University of Pennsylvania, and then some on the hardware end. Since the trials, one of the main things we've been focusing on is the gripper. We've experimented with 3D printing for different forms for the hand.
We're testing different type of hooks and end effectors to see which one is more effective.
In terms of software, we know that the network changes from the trials to the finals are significant. We've been trying to add more autonomy into our system rather than a lot of the teleoperation that we've had in the trials.
Everything's modular. As a matter of fact, the user interface is simply a laptop and a tablet. We can actually use it on a smartphone if we want to.
Our team tries to focus on having low-cost motors with low-cost standardized brackets that together form a very good system.
We're planning to attempt every task in the DRC things. However, the rough terrain task is probably the most difficult at this time because the range of motion of our legs are not yet quite there that can handle the rough terrain.
Do you just want to make this further away? Small teams have their advantages for getting things done, but they also have their disadvantages. So when something breaks, you have to fix it, or you have to find some other person who has the time to fix it.
Our lab, Romella at UCLA, is now very, very famous. Kids, adults, everyone wants to see the robots. My son thinks I'm Tony Stark. He believes I'm building robots to save the world. And as a matter of fact, that's actually what we are doing. So without math and science, we won't be able to do all these cool things. It's great to inspire the young kids, young generations, to show not only useful things, but to save humans' life.
About 1 month after the DARPA Robotics Challenge, we will program our robot to play soccer in the International RoboCup competition, which will be held in China this year. We competed last year in Brazil, and so we hope to win the championship another year, and we'll see what happens with our robot after that.
So that was a closer look at Team Thor, but we'll shift our attention now to the blue track where Hercules, the Atlas robot, has earned its first point by successfully completing the driving task. Now it's on to phase number 2 of the competition, which is egress. Should also be noted that Team SNU also picking up a point for walking through the door as you continue to watch Hercules. So over on the blue track, as I think everyone saw and heard, Hercules, the Atlas robot on egress, trying to complete the task, has fallen. We have seen some other robots actually fall on egress, and unfortunately for Track Labs, the robot actually didn't fall within that yellow box. Team MIT did fall yesterday into that box and was still awarded a point. But you have to be completely into the box. So the dismount, although not pretty, get in the box, you still get a point. Track Labs once again will take another reset. That'll be their second, which means now a 20-minute penalty. Shift our attention while Track Labs tries to get Hercules back on its feet. We'll head to the yellow track. Thormang is the robot. So Thormang at this point has collected 2 points thanks to a successful drive and then getting through the door. Looking for a potential third on the fourth task, and that would be the valve, assuming that Team SNU does decide to go with this task. Some of the teams have opted to skip around. But let's take a closer look at Team SNU.
I'm Jae-Young Park, the team leader of Team SNU. Our team started very late, so our hardware is from Robotics. So the name of the robot is Thormang, and then we wanted to use software that we developed in our lab, which is about whole body compliant motion control algorithms. But somehow the robot cannot support our control algorithm very much. So we decided to use most famous algorithms best suited for this competition. It's a really competition, and behind the scene, people start to collaborate and exchange ideas and share the theory and experiments. I think that's the best part of the competition, not the competition itself. I really like the challenge, and over the course, toward the final, we work together and share this knowledge, and I think that's the most important part of the competition. Sometimes people hate robots because a robot takes over the jobs of humans, but in disaster area, it's a completely different story. I really believe that the robot is needed in disaster area. Yeah.
So once again, that was a closer look at Team SNU on that yellow track. If you're keeping tabs on what's happening on green, we're once again looking at a reset for Team Thor, their second. And over on the blue track, Track Labs still waiting word on the status of Hercules, the Atlas robot that took a massive fall. And as you can see, there is fluid all over the course. And on the initial fall, looked like there were some pieces that also flew off the robot. Hasn't stopped some other robots, by the way, when pieces fall off of them. We did see a little bit earlier in the competition, another robot actually lost its head, a team from South Korea, and yet they were able to reattach and continue on with the course. So now for the rest of this round, number 4, just 2 tracks to keep an eye on. It is yellow and green, just getting official word from DARPA representatives. Blue track is officially now, it's a wrap over there. Track Labs has pulled Hercules out. So now a third point for Team SNU, a successful drive, successful passage through the door, and now a 360 turn on the valve for Thormang. This is where things sort of get interesting for some of the teams. After the valve task, we have seen other teams elect to pass on the wall because of the precision. Dr. Gil Pratt, who's the program director at DARPA, told us it was more of a strategic element that some of these teams decided to execute that game plan. The wall task actually is pretty precise, and because of the degraded communication early on in the hour, because as the hour continues on, the degraded communication actually gets better, that some of the teams have opted to take a closer look at some of the easier tasks, try to complete those, earn their point, and then circle back when the communication is better between the robot and the team inside the garage to go then complete that wall task. We continue to track the progress on the yellow track, Team SNU. And as you can see over on blue, a little bit earlier from Track Labs, it was the Hercules robot taking a spill. We had a little bit of a bleeder, so they're trying to clean up the track over on blue. To be fair though, Hercules not the only robot that's taken a spill in the competition. Yeah, that was kind of awesome. Let's take a closer look on what's happening on the yellow track. We just saw Team SNU pick up the point on the valve. Speaking of falls, Thormang a little wobbly right now, trying to decide which way it wants to go. We're still waiting on the completed reset on green with Team Thor. It was their second, so a 20-minute penalty in terms of time. Remember, 1 hour, 60 minutes to complete 8 tasks. If you want to keep tabs on the standings real time, you can download the DRC Finals app. It's good for iOS and Android devices. Also give you a better idea of what's happening at the expo.
Power strip, we got that?
Well, they're headed up with a. You need a strip and an extension?
No, if I
They're
have
headed
power
up with an extension right now.
Okay.
We'll continue to check in on the progress on both the yellow and the green tracks. Made reference to the degraded communication, how difficult it is for the teams in the garage to communicate with the robots once they get through that door. Here's a closer look at what is making the finals so difficult for all the teams that are competing.
Disasters occur more often than we would hope. What robotics really can do is to give us more resilience, to try to stop the disaster from getting out of hand. Can we have a robot go in where it's too difficult or too dangerous for a person to go in order to just tamp down the disaster so it won't be that bad? We've had robots that can operate in disaster zones for a number of years. The problem is those robots require nearly perfect communication between the operator and the robot. In a real disaster, communications is actually quite difficult. We need to build machines that can operate effectively as if communications were perfect, even when communications is really degraded. In the DRC trials, we allowed the robots to be suspended with safety ropes in case they fell. We also gave them power cords, and they had very high-performance fiber optics that connected them to the human side of the interface. In the DRC finals, we took all that away. We're trying to get more authentic to the actual circumstances, the austere circumstances of a real disaster. And so if the robots fall, they will fall hard on the ground. The team will be allowed to have the robot try to get back up. And if successful, it'll get back up and keep on going. We've also gotten rid of the communications tether. And so the robot has to now communicate using the same kind of wireless technology that you might have in your home for Wi-Fi devices. And then finally, we removed the power tether. The robot has to carry all of the energy supply, all the fuel for its work on board, good enough for lasting an entire hour. This really is a wide spectrum of different teams from different parts of the world, and they all have different approaches to how to solve the problem. Some of them are bringing robots of their own that they've built. Some of them are using the Atlas robot that DARPA has provided. Some of them are getting funding from us. Some of them are doing it all on their own funds. Part of my role as a program manager is to establish that level of difficulty. We expect a significant fraction of the teams to not do well during the challenge. We expect some of the teams to do well, and that, if that occurs, it means that I've set that difficulty just right. The DARPA Robotics Challenge is really only the beginning of work on disaster response robotics. There are going to be a number of challenges internationally after ours. We expect that very much like the Olympics, that this challenge will continue to move around in the world, and then eventually at the end of this process we will have a robot that could really be transitioned into something that the disaster community could use.
As Dr. Pratt was referencing sort of the communication issues that the teams are having once the robots actually get through that doorway. As you take a closer look at what's happening on the yellow track right now, Team SNU trying to complete the wall task. And if you're not familiar with this particular task, we saw some other robots in the competition yesterday skip this task. It's considered one of the more difficult ones because of the precision that it takes. So essentially what the robot has to do is pick up a cordless drill off one of those shelves, remove it, and then cut into that drywall. So it's about a ½ inch thick. And the task is really to cut around the circular shape that's there. You can't hit the frame, but the entire dark shape has to be completely removed. So once it's cut through, then the robot wants to push through, so that's a complete hole. And officially another point on the yellow track for Team SNU. And that is maybe the best looking circle we've seen over the course of 2 days of the competition. Yes, it's okay. You can celebrate. Remember, doing this task with the degraded communication, certainly not easy. It's a lot tougher than playing your video games in the dorm room. Well, the wall task is complete, but the day certainly not over yet for Thormang. Next task, if they choose to execute it, will be the surprise task. And with representatives from Team SNU attending to Thormang, it looks like a reset is coming, which will be a 10-minute penalty. Don't want to forget about what's happened across the way at the Expo. Coming up in actually just a minute or two, Flyability is going to demonstrate the Gimbal. It's a collision-tolerant flying robot that uses a protective frame to both fly and roll around in an energy-efficient manner. Once again, it's coming up in just about a minute or so in the unmanned aerial vehicles area in the Expo. Also at the Expo is a sort of a museum-like hallway. Gives the history of DARPA. Here's a closer look at that history.
Let's talk a little bit about DARPA's history. It all started with Sputnik in 1957. Human beings put the very first artificial satellite on orbit. The humans that did it were the Soviet Union, and at the height of the Cold War, that got a lot of attention in the United States. We didn't like being surprised. DARPA was created to prevent that kind of technological surprise. Our predecessors here at DARPA set out to create a few surprises of their own, and that's what we've been doing for nearly 6 decades now. The investments that DARPA has made over the years have changed how we fight. Think about stealth aircraft, think about battle networks, think about precision-guided munitions. That's how we have overwhelming military power today, and those technologies trace back to very early investments that DARPA made. At the same time, we're investing in the underlying technologies for those military capabilities, and those technologies have changed how we live and work. Early in the 1960s, DARPA decided to start connecting computers and started something called the ARPANET. Over a few years and a lot of amazing work by a huge community, that evolved into today's internet. Our job at DARPA is to build breakthrough technologies. Sometimes we start with some of the most amazing basic research the world's ever seen. Here's an example of some work that began with Nobel Prize-winning physics a couple of decades ago. People were shooting lasers at atoms to cool them down, and now they can make clusters of atoms that are colder than any spot in the known universe. Beautiful science. But we're harnessing that science to build some advanced instruments. We're building the most precise clocks, the most precise gyros that the world has ever seen. And it's a great example of gorgeous science, but also some applications that are going to change our futures. You might remember that at the height of the Ebola crisis, one of the Ebola victims got an experimental therapy. It was a vaccine that had been grown in tobacco plants. That actually traces back to a DARPA program called Blue Angel, where we helped demonstrate that that was possible. And it's a great example of some of the new frontiers of research in the biological sciences at DARPA today. One aspect of the work that we do at DARPA, our focus on leading edge technologies, is that we sometimes find that we're the first to stumble into new societal issues. And it's very interesting to watch those issues play out. Our job at DARPA is twofold. Number one, our job is to pursue these powerful technologies for our nation and for the world, to make sure that we understand what's possible and to have that forward view into new capabilities. But at the same time, we also have the job of making sure that we raise those new ethical issues, these broader societal issues. And we're not going to make up answers to these questions, but we want to engage a broad community and get those conversations going so that we can, as a society, make better choices about how do we balance between privacy and the value of big data. How are we going to harness synthetic biology and unleash its possibilities while minimizing the safety burdens? These are the kinds of questions that we grapple with, but again, with a much larger society around us.
So back here on the DARPA set, it'll be round number 5 that's going to be kicking up in about 40 minutes or so. Mark Raybert from Boston Dynamics, he joins us. We're about to see another demonstration right on the track. It is great to have you back on set with us. We were talking about Spot a little bit earlier. A little different demonstration than we saw a few hours ago. In fact, we're going to have 2 robots out on the track. Take me through what we expect to see.
So we have 2 Spot robots. You can see them both out there now. We were holding the second one in reserve in case the first one had a problem, but we figured this is the finale for Spot's performance, and we thought we'd bring them both out.
So what makes Spot so unique?
So Spot's a 4-legged robot, and the key thing it does is uses active balance. That means that it's always keeping track of how its body moving with respect to its feet. It's got a gyroscope on board, a solid-state gyro. And its computer can react to disturbances and it can react to the environment.
The mobility looks pretty unique there. We just saw a move from one of the Spots out there. How do you get the robot and those legs to twist and manipulate the way that they're able to?
So we've been working on designing the control for robots like this for quite some time, and with DARPA sponsorship have built a whole series of quadrupeds, and Spot just is the culmination of that whole series of developments. It's got some new tricks it does where it coordinates stepping and makes decisions more frequently about which leg to use and how to use it, and it just gives it a real agility and versatility that goes beyond what the previous ones have done.
Mark, how does it handle different terrain?
On terrain, it uses a combination of sensors in the legs, but also on the front there, you can see there's a thing that looks like a coffee can, which is a laser rangefinder, and there's also a stereo camera that can look right in front of the robot and look at the shape of the terrain. So it uses those sensors to go upstairs, to estimate the ground plane, to go up hills, and things like that. So this robot does very well on rough terrain.
So you mentioned cameras that are on board. What happens when there's an obstacle? How much autonomy does Spot have?
In this robot, we haven't done too much work on the autonomy, but we have in others. And the robots can use information from the cameras in order to decide that an obstacle is too big to step over, so it'll go around it. We've had it going in hallways where it travels very quickly using the sensors to keep it away from the walls while a person drives it.
What's the range on the robot?
I think it can go a few miles. I think earlier you asked me top speed. Top speed's about 8 miles an hour. I had it wrong earlier. And it can go for about an hour on one battery, so that should take it about 8 miles, something like that.
How difficult is it to control and really force movements for the robot?
So we do the hard work in the programming of the robot so that the driver actually has a very easy job of controlling it. They just tell it the speed and direction to go, and maybe in this case tell it which of the gates to use, and then the robot figures everything out for itself.
I see Sarah Kustok actually down on the track right now. Yeah, you can wave, Sarah, it's okay. I'm wondering if she's capable of controlling the robot. Do you think she'd have a problem with that?
No, I think, you want to give it a try? Hey Al, can she?
Yeah, Sarah, stand up. Let's see if you can control this robot. I'm going to put you on the spot. You've been making fun of me for the last 3 days. Not that I'm hoping for a choke job from you.
Watch this, Mike.
So that's Ben Swilling, one of our 2 master Spot drivers. And he's going to show Sarah how to use the controls.
So Spot ends up in the stands, we know exactly why.
Say it again?
If Spot ends up in the stands, we know why.
No, look, I'm going to walk him towards you.
So there was no advanced training. So this is, I don't know what Ben's doing. He's probably switching it into a little bit friendlier mode of operation.
So that's pretty incredible, though, when you consider, I mean, Sarah has some experience with some of these robots over the last 2 days. She's been playing in the expo nonstop with a lot of these games, but to take over, I don't think she's had the the opportunity so far to take over the controls of a robot like Spot, and it seems like, well, Spot hasn't fallen just yet, so that's a good sign.
The whole idea has been to put enough of the smarts in the robot so the operator doesn't have to worry about all the details. So all she has to do is tell it what speed to go or how to turn, and the robot figures out how to do all the stepping and the balance and the rest of it.
Oh, really? What an impressive robot.
Now they
She
put it in
wants the
skipping
dance
mode.
going. Fantastic. Well, Mark, really appreciate you stopping by with us. It really is an impressive robot, and I don't think Sarah wants to give up those controls. She just did.
I just did. That's awesome.
Good job, Sarah.
Thank you.
All right, Sarah, I know you're not done just yet. I had to put you on the spot. No pun intended. You're not done. I know you're standing by. You had a little bit more for us down on the tracks.
Yes, I do. And the next demo, I believe, is I'm looking for Akira, is it?
Okay. Yeah, sure. Thanks.
You come on over here. All right, now I'm here with Frosty Design, correct, Akira, and your robot is Frosty. Tell me a little bit about it.
Yes, this robot is my hobby robot. Learning and get up myself.
Okay, let's see. Can we see what it does here? Let me get you set up. Just now as the spots walk behind us, I won't ask to control this one for you.
The only thing different with MIT is in the empty spot. Everything else is the same.
Perfect.
Oh, nice.
Perfect.
So it can jump? Is that, what are some of the main functions of Frosty?
It's this one, learning and get up myself. Okay.
Wow, you can see the mobility. Oh. Yes, big round of applause. Incredible. And how, can you explain a little bit more about that function, the ability to get up so quickly?
Sorry, pardon.
With the fall, what is some of the structural design of this robot that it was able to get up and move? And it seemed like it had some contraptions coming out of the back once it did fall. Yeah. Did you, what's the main parts of this robot that you like to highlight?
This is original leg link system, and leg system is the original link system. It is jumping.
Yeah, the jumping, and you're very, very cool. Thank you so much, Akira, and to Frosty Design and Frosty. And I think, as the crowd can see, this is a very fascinating robot. We look forward to watching more.
Sarah's having all the fun down on the track. Once again, round number 5. It's going to kick up in just a short bit before we can get Pam Melroy to sit down with us and talk about what DARPA is working. She's the Office Deputy for Tactical Technology for DARPA. It is great to have you back on set with us. Give me a sense of what, I mean, we talked earlier this morning. Now you've seen a couple more rounds. You watched a bunch of rounds yesterday. How has this all played out for you, this challenge?
We are absolutely thrilled. It's amazing. We set the bar very high for the teams, and everyone went for it. And not all the robots were successful in every task, but they certainly put their heart and soul of the team into it. And we're just thrilled to see everybody out here enjoying this amazing technology with us.
Pam, I know you're a former astronaut. Post-astronaut career, why go to DARPA?
DARPA has a fantastic mission of creating technological surprise. It's a thrilling place to work because there are a lot of really smart people who are thinking very creatively, and they're given the freedom to think creatively. we move very quickly, and part of the way that we do that is people only come in for 2 to 4 years. Being a DARPA program manager is an exciting, thrilling job, and people are eager to change the world in just those 2 to 4 years. So everyone is bright, energetic, and completely passionate, and it's a wonderful place to work.
Now, I know a little bit earlier when we spoke, we were talking about your experience at the expo and the fact that we had all these younger students that were taking part, and saw Audrey down there working the remote control on her 7th birthday, which I'm sure was a thrill. I met her earlier, by the way. She was wearing a Yankees cap. I told her she couldn't sit on the set. She was quick to take that off. So I was a big fan of that. But how gratifying is it for you to see all these younger students out there? We have some high school students that are even helping out with some of our teams that are competing today, to be involved in a process like this.
It's fantastic. It's actually very much part of our goal. Part of the reason that we made this actually a public event is to inspire future generations of DARPA program managers. And for a program manager at DARPA, we pick the smartest people that we can find, and the creative people, the people with a passion and a vision to create a capability. And I've seen a lot of that spark here. And I'm very excited to think that some of the students that have been participating, or even the ones sitting in the stands or working out at the expo, are going to be program managers who will be doing future grand challenges with DARPA.
So what's the best case scenario based off of what some of these younger students are seeing? If you had to fast forward 10, 15 years, maybe even 20 years, depending on how old they are, what would your message, more specifically, I should ask, be for some of those students that are interested in robotics and technology?
Well, I think we've seen that it takes about 10 to 15 years usually for the technology that we develop at DARPA to become ubiquitous everywhere and frequently used. So I think that the technology that they're working on today, in 20 years, when they might be a program manager, or even before then, people will say, wow, you worked on it back then, at the very beginning? I think that we will see these technologies proliferate in ways that we don't even expect, not just in disaster robots, but in other ways that robotics can help the human condition. And these students are the robotics experts of the future.
Well, Pam, it has been a pleasure once again to have you on the set with us. I know we have maybe the best robots still left in the competition to be showcased. It's coming up in about 15 minutes time, round number 5, and then in less than 2 hours, I should say, we'll also see round number 6, where the top 4 teams will be competing. So once again, thanks for stopping by with us.
Thanks, Mike.
Mentioned some of those top teams. Take a closer look at that leaderboard. A lot of eyes will be on Tartan Rescue, that team that has the robot named Chimp. The only robot in the competition to score a total of 8 points, did it in less than 60 minutes. And it was also the only robot in the competition to take a spill, fall to the ground, and get up without a reset. Getting up on its own power, certainly that was what rallied the crowd in the stands. So once again, Chimp will be competing in round number 6. Just 2 more rounds of the DARPA Robotics Challenge. It is the finals of 2015. Round number 5 is upon us, creeping oh so close to finding out who's going to win that $2 million prize. So round number 5 is officially underway. These are the best robots in the last 2 rounds that we saw after rehearsals and yesterday in round number 1. As we take a closer look at what's happening on the green track right now, it is Team Keist taken off. They were one of the fastest yesterday in terms of the drive, and you can certainly understand why. 7 points after round number 1. They did it in 58 minutes, 21 seconds. That was good for a 6th place finish, and as your first points of round number 5. Over on the yellow track, it's DRC Hubo at UNLV, also very quick. They've earned themselves a point. One of the interesting things you want to keep an eye on while you're scoring this, you can do so on your app, on the DRC Finals app. It's got real-time scoring, but keep in mind, drive is the first task. As you take a closer look at the blue course right now, IHMC Robotics, the running man Atlas robot, yesterday competed in round number 2, destroyed the competition in those first few rounds, and has spearheaded itself into round number 5. I will not be announcing points the rest of the way. I think other people can do that for me, apparently. Let's head over to the green course right now, where it's Warner the robot from Team WPI CMU. Excuse me, the green track, I should say. That's Team Keist. Warner the robot sitting on the red track. So yesterday, Team Keist, one of the more impressive robots, one of the first ones to be able to completely get out of the car by itself to earn that point for egress, which is the second phase. As you can see right now on the yellow track, Metal Rebel. Team is going to take the reset, which essentially means a 10-minute penalty, and they will not be able to earn that second point. So right now on yellow, the most points that Metal Rebel will be able to potentially earn will be 7. Yesterday earned 6 points. Earned 6 points yesterday in 57 minutes, 41 seconds. They did not participate in the egress either. Let's head back to the blue track right now, where it's Running Man trying to get out and perform egress. First robot to do that in the competition yesterday. In fact, it earned 7 points. The only thing it didn't do was climb the stairs. Ran out of time. We'll see if the Team HIMC Robotics takes a more aggressive approach and tries to get to the stairs a little bit faster, earn 8 points. Take you back to green right now. It's Team Keist. You'll notice that some of the robots are small enough or agile enough to be able to sit on the driver's side of the Polaris Ranger XP900. Some of the robots actually have to sit on the passenger side and use their limbs to control the steering wheel. One of the advantages of being on the passenger side, a little bit of an easier path to get into that safe zone, which is that yellow marking that you see next to the Polaris. Once the robot officially gets into that area, that will earn them a second point for egress. So officially on blue, that is a point for the running man Atlas robot for egress getting into that area. Meanwhile, over on green, Team Keist is cruising. They've just earned another point for the door task. Keep in mind for the door task, as running man over on the blue track gets set to do it, it's not just about opening the door. You have to find your way through the actual door frame. You'll see that yellow line right on the floor. Robot, as soon as it closes out through there, it'll pick up that point. So right now, Team Keist working on the valve task. If it's your first time seeing this task, fairly straightforward here. Robot just has to grab onto the handles, rotate the valve 360 degrees. How you can figure out there's a piece of black tape as a marking point for the DARPA officials who are scoring. As you're watching Team Keist try to execute the valve. And continue to show off. They've just now earned another point. Keep close tabs on what's happening also on the blue course with the running man Atlas robot. Looks like it has just grabbed the handle. Needs to push that door forward. If memory serves me correct, yesterday in round number 1, what you're seeing on the blue course, the Atlas robot running man actually didn't walk straight through. I believe it actually turned to its side and sidestepped through the door path. Now, an interesting development is actually occurring as you take a closer look at running man, and I guess my memory was a little bit off, getting right through that door passage. Make it now 3 points for Team IHMC Robotics. Make reference to what's happening on the green track right now. Yesterday, for Team Keist, they did earn 7 points in under an hour. The one task that they did not complete was actually the wall test. In fact, they decided to skip the task and then circle back. But right now, Team Keist is sitting at the wall, so we'll find out if they're going to try to drill. It's a good time to remind everyone about the communication that's happening at this point on the blue track and the green track. The robots during the drive task, egress, and getting to the door have perfect communication with their team that's sitting in the garage not too far away. Once they get through that door, degraded communication takes into effect. And what essentially that means is what the robot is seeing and what the team is seeing, the signals are just not as strong. So I I compare it to basically being on a cell phone conversation is to take a closer look at what's happening on yellow right now. Compare it to what's happening if you're on a cell phone conversation and you're only hearing every other word from the person on the other end. The best robots, the strongest robots, as we're going to see another point here scored by DRC Hubo, UNLV, earning their second point on the third task. The best and the strongest robots are the one that have the most autonomy. So once they get through that door, if they're able to execute commands without a lot of instruction, they typically are able to excel. It can be really frustrating for the guys inside the team garage as they're trying to communicate different commands and what they see. So for example, one of the reasons strategically Team Keist initially yesterday, the thought process was they didn't complete the wall test, they skipped it because of the precision that it takes. So once they get through that door, let's say every 30 seconds, they're only getting about 1 second worth of information back in the team garage. So the robot actually has to create some sort of virtual map to try to figure out how to complete the task. Now, as the hour continues on, the communication actually does get better. So a harder, difficult task like the wall, for example, that requires a lot of precision, actually might be a lot easier a little bit later in the hour. Let's take you back to the blue track where it is Running Man trying to earn yet its fourth point on the valve. So while Running Man is trying to complete the valve task, so is Metal Rebel over on the yellow track. And they officially now get that point. Let's head back to blue right now and see how Running Man is doing completing his task. Still waiting to find out from DARPA officials. Yep, that looks like it's good. I want to show you what's happening in the garage right now. I mentioned that degraded communication and the virtual map that the robot has to try to create. Here's a look at what the team is looking at on the right side. So as you can see, it's a little bit more difficult than playing a video game. Standing by right now with the representative from the IHMC Robotics team. Sarah, they brought their fan club today.
It did. Plenty of excitement over here with IHMC Robotics. And before we get to it, as I'm joined by Nick Payton, we heard the cheers as you just accomplished the point with the valve, but you got some actual running men, some hats going. Where did the fan club all come from?
It's important not to take yourself too seriously when you're doing this kind of thing. So we had some guys bust out morph suits and dress up like our mascot, and one of our engineers brought back a panda head logo with him when he came back from Japan, and that evolved into the silly hats that most of our pit crew's wearing.
And Nick, as I just said, so you've made it now through the VAL. What is your assessment of how Running Man is progressing so far in this run?
He's running smooth, running steady. We're getting up to the drill now, and hopefully we'll be able to fix the problems we had getting over the rubble last time and make it all the way through.
Yeah, you mentioned that you accomplished every task except for the stairs yesterday. What do you take from that? What were you able to learn to hopefully make today more successful for your team?
Well, the issue on the stairs was mostly a time constraint, we think. So figuring out where we had problems earlier, getting that straightened out so we can run cleanly all the way through, we expect to be able to make it all the way.
All right, Nick, we certainly appreciate your time. Good luck to you and your team as you continue on.
Thank you very much.
All right, Mike, back to you and the green track.
All right, Sarah, here's a closer look at Team Keist on the green track, as you just made reference to. Mentioned this a little bit earlier, but yesterday, the DRC Hubo robot, Team Keist, did very well in the competition. 58 minutes, 21 seconds, able to earn 7 points. The one task that they didn't do was the wall task. So that is another point for Team Keist on the green track. That is easily the best circle that we've seen so far in the competition. For some of the other robots that do have to still complete that task, it's essentially just drilling through. It's not only just the drilling aspect, but the robot has to pick up one of those cordless drills on the wall and then drill through about a ½ inch thick drywall. Have to cut around the circle, and as long as you don't hit the frames, you're in good shape, and then you have to punch through and leave an empty circle, just like Team Keist just accomplished. Meanwhile, I think some people are trying to figure out what's happening on the red track. Team WPI CMU, they are swapping out cars. Every single one of the robots that's electing to do the drive is driving a Polaris Ranger XP900. The good news for them is there's no major issue with their robot. In fact, they're swapping out cars, so they will get a full start. Their clock will start at 3:45. They have not been penalized. There's no issues right now. I'm going to take you back out to the blue course. Where? Let's head back to the green course for Team Keist. It's been cruising through. So far, the best finish that we have seen, or the best results in the early goings we've seen so far on day number 2. They've completed all of the tasks so far. They've earned 5 points in this round. Up next, the surprise task. Really requires a lot of manipulation. On the rehearsal day on Thursday, the surprise task was a push button cutoff switch. Yesterday, it was a pull switch, and then today it's a pull the plug and then replug into the other outlet. With representatives from Team Keist right now standing by with Sarah.
Thank you, Mike. Yes, with Kang-Kyu Lee, and a nice moment here for your team, because the only task you didn't accomplish yesterday was the wall, and your robot just did that. How were you able to make those improvements as your team headed into today?
We practiced very a lot yesterday until in the morning today. So I think we are very doing good until this moment. So yeah.
What was the difference that allowed your robot to accomplish the wall here today?
We modify some of motion of our robot, and many practice of it.
Wonderful. Well, good luck as the robot continues to progress, and we appreciate your time.
Thank you. Thank you.
All right, Sarah, so once again, Team Keist completing extra work, and a lack of sleep actually paying off for Team Keist as they were able to complete the wall task. Let's take you to the yellow track. Metal Rebel from Team DRC Hubo at UNLV trying to complete the wall task. They've already earned 3 points. Remember, they did not egress, and they did take a penalty of 10 minutes. So this would potentially be point number 4 for Metal Rebel on the 5th task. Heads back to the blue course right now, where Running Man is still working on that wall task and has begun the drilling process. So that's another point on the blue track for Running Man. So that is now 5 points for Team IHMC Robotics. Take you to green right now. Team Keist still working on the surprise task. Pull the plug, and it looks like it's done that. Now the second phase is to take that plug and put it onto the other outlet to the right. So currently on the large Jumbotron in the middle of the track, we're on the green track as we're watching Team Keist trying to finish off the surprise task. It's getting a little bit close, but if you're wondering what's happening over at yellow, it's another team reset on the wall for Metal Rebel. That'll be the team's second reset. So now a total of 20 minutes have been docked from their 1 hour time. Remember, they took a reset after the initial drive for the egress. Some more good news on the green track. They've officially now earned the point. Time to get excited in the Team Kais garage. I think it's time to check some IDs in there. Now keep in mind, with regard to the standings, Team Kais was actually just behind Team IHMC Robotics. Both teams had tallied 7 points, but it will also come down to time. So at this juncture, it is sort of important to note that on that blue track, if Running Man's able to complete this task relatively quickly, it really would give Team Kais a run for their money. On that green track right now, an opportunity for the rubble task. The robot has an opportunity to take 2 different paths. You can go left or you can go right. Yesterday, just for some perspective here, Running Man did fall on the rubble when it chose to go to the right side with the cylinders. Now on the left side, Team Kais trying to either, you can roll through it, you can go over it, or walk over it, depending on the functionality of your robot. There's also an option where you can move the debris. Have yet to see a robot try to move the debris. Just in case you're wondering, those pieces of debris, nothing weighs more than 5 pounds. And in this case, Team Kais is going to try the approach that they did yesterday, and that's just roll right through it. So another point scored for Team Kais. Now make it 7. That ties their total from yesterday. We'll shift our attention back to the blue course. Team IHMC Robotics still trying to complete the surprise task. And that's official. So 6 points on the blue course for Running Man. We'll go back to green. Our Team Kais is going to try to conquer those stairs. Obviously a ton of action happening in front of us on the tracks, but just in case you're interested in what's happening over at the expo, you can stop by the unmanned aerial vehicles area at 4 o'clock. The University of Pennsylvania's GRASP lab is going to demonstrate a formation flight with a swarm of multiple unmanned aircraft. Once again, that's coming up at 4. So over on the green track right now, Team Kai's trying to conquer those stairs. I want to give everyone some perspective on just how much more aggressive the robots are taking these tasks today compared to yesterday. Yesterday, they earned 7 points in 58 minutes, 21 seconds, and they skipped the wall. Today, right now, if you were following along in your DRC Finals app in real-time scoring, you can see Team Kais is now firmly into 3rd place. They've completed 7 tasks in 36 minutes and 14 seconds. Yesterday, it was fun to see Running Man on the blue track try to get over the rubble. If I'm not mistaken, on the first run, not that I'm trying to jinx it, but Running Man did fall. Had to do a reset and conquered it without a problem. So while Running Man's trying to get over the rubble, we'll check in quickly on the green track where DRC Hubo from Team Keist is making its way up the stairs backwards. Let's take you back to the blue track and see if Running Man can finish off this task. We'll make our way over to the green course and Team Keist. Take you back to the blue course. Running Man will try to climb the stairs. It was the first robot yesterday in the competition to complete the task. And Team Keist, with a perfect score with 8 completed tasks, is now your leader in first place. Did it in a time of 44 minutes, 28 seconds. Just to give you an update on what's transpiring on the red track, Team WPI CMU, their robot's name is Warner. Yesterday competed very well with 7 points. They had to swap out cars, so their start time will be 4:05.
So that delay on red is going to hose our whole day.
Just to keep everyone updated on the yellow course right now, DRC Hubo, team from UNLV. Their robot's name is Metal Rebel, just picking up its 4th point. So we will get our first look at Team WPI-CMU making its way down the driving course, and to keep you updated, Team IH to keep you updated on the most current standings. Little celebration over on the blue course, and you can understand why. Team IHMC Robotics now in 2nd place overall in the competition, completing all 8 tasks in under 51 minutes. Meanwhile, Warner the Robot on the red track, earning its first point, successfully completing the drive. Some photo opportunities over on the blue track, where Running Man certainly thrilled with its position. As I mentioned before, now in 2nd place in the competition. We'll take you back to the red course. Ooh. Running Man a little tired. Ooh. Running Man just taking a little bit of a breather, but we'll check back in on the red course, where Sarah is standing by as one of the robots trying to egress and pick up a 2nd point.
I'm here with Michael Jenner.
We gotta get to
we're going to get started with our interview here.
You need to back up, sir. Back up, please. Back up, area.
Oh, and we're all right. We're just going to talk now. Warner, a fresh but delayed start for Warner. Vehicle troubles. What has been just some of the emotions as you awaited to finally get this start?
Well, we got off to a good start, and then we stopped halfway down and didn't know what was going on. It was very nerve-wracking to see Warner out there doing nothing, but it wasn't his fault. It was the vehicle.
Now you finally get a chance to get going, and of course yesterday the only task you didn't complete was the wall. What were some of the adjustments or improvements that you guys looked at both last night and today as you got set for this race here once again?
Yeah. We normally do great on the wall task, but this wall was a little bit of a problem, so we practiced this morning and we nailed it, and I think we'll do great today.
A lot of excitement, I'm sure, right now as you get set. You see some of the other robots continuing to complete tasks, but when you look at your team and what they're set for to focus on with Warner, what was the biggest emphasis as the trial continues here?
Well, we've been practicing and working on this for 2.5 years, so we're just happy to be here. We had a great run yesterday, and I think we'll do better today.
All right, Michael, we certainly appreciate your time, and good luck as Warner continues his run.
Thank you, Sarah.
Yeah.
All right, Sarah, so once again, Warner the robot, good news for Team WPI CMU, knowing that the robot was just fine. It was just an issue with the vehicle. And just to give everyone an update on the yellow track, Metal Rebel has just been awarded an extra 3 minutes in its round. Someone also just came by and told me, since we're on a racetrack, it is fairly appropriate to announce American Pharaoh, the 5th horse since 1948 to win the Triple Crown. And over on the red track, Warner the robot picking up a 2nd point for a successful egress. Here's a closer look inside the garage for Team WPI CMU. Remember, communication right now for Warner the Robot, perfectly okay with the team representatives back inside that garage. Once Warner is able to successfully complete the door task, that's when the degraded communication will then begin to step in. Let's take a closer look at this team.
My name is Tashkun Padar. I'm an assistant professor of robotics engineering at WPI.
My name is Chris Atkinson. I'm a professor in the Robotics Institute at Carnegie Mellon University.
And our robot is Warner. I think our robot and our software development is unique because of our team. We are primarily two institutions. We are 9 hours apart by a drive. But then more importantly, on a given day in our lab, we see high school students, we see postdoctoral researchers, professors working on the robot. So I think that whole team effort makes us unique.
But essentially like this. You had it out like this. The WPI part of this team was sort of uninvited to the party. They weren't one of the original funded teams. Instead, they entered the Virtual Robotics Challenge, and they sort of proved to the world that they deserved a seat at the table by beating most of the other teams, which was a big surprise to everyone. And that is what got them into the DARPA Robotics Challenge.
DRC has been a major activity in our lives for the past 2 years. So our families, our friends, our colleagues are excited us to see that we made it to this point. But then I think everybody also understands the grand challenge that we are trying to accomplish here or face here. So they're all supportive and they want us to do well.
Okay, go ahead. I think the biggest set of challenges that we face is that we make assumptions about how the contest is going to be like. And then it turns out that our assumptions are wrong. We have to find a way to get the robot to be able to walk into the competition environment, see what's there, and then figure out how to do it, rather than us programming our assumptions in advance.
Try that. Our minds are with this challenge all the time. You know, our students are thinking about it, our team members are thinking about it, our families are thinking about it too. So I think what will make us succeed in this challenge is to stick to the problem long enough. And what is that long enough? We will find out.
A little more FaceTime for the leaders of WPI and CMU. Can understand why there's some excitement for Warner the Robot getting that door open on the red course. Just needs to cross that yellow line to pick up that point. That would be 3. Let's move along to the yellow course, where Metal Rebel has had 2 resets so far in the round, but is trying to complete the rubble task using the same approach Team Keist did, which is just sort of drive through the debris. More good news from Metal Rebel, earning the point on the rubble task. Take you back to the red course, though, where Warner the Robot trying to sidestep its way through the door. So now a third point for Warner on the red track, getting successfully through the door. Take you back to the yellow track where Metal Rebels trying to conquer the stairs. Should be noted, by the way, what was happening on red with Warner. The next task, at least as it lays out, would be the valve, followed by the wall. It'll be interesting to see if they decide to skip the wall, which is something that they did yesterday. Getting back to the yellow course, Metal Rebel finishing the drive, the door, the valve. Did not earn a point, though, for the wall, but did pick up a point for the Rebel task, making now 4 points in this round as we take a closer look at Team DRC Hubo at UNLV.
My name is Paul O, and I'm from the University of Nevada, Las Vegas, and I represent the team DRC Hubo at UNLV. Thinking back about Miami, and I remember something, you know, creation is always painful. And something so unprecedented like the DARPA Robotics Challenge, and trying a design and then realizing that's not working. And going back to the drawing board and really trying to come up with creative approaches, that's always been a painful process. And not that we're masochistic, but that's what continues to be, you know, I think what designers are all about. So what kind of hours are we putting into the DRC Pro? Is that maybe 30 hours a day? That's one way of putting it. You know, we work hard, but we also play hard, or at least we try to. There's times where the team is putting in all throughout the night, you know, some of them, and that's the great thing of working with students at UNLV. Just that energy that these, you know, 20-something-year-old kids can do, it really drives the rest of us. A core value for our lab is about inspiring wonder. For us, that one event that I think really inspires people's wonder is the robot driving the vehicle and egressing. You know, if everything's important, nothing's important. And so I told the team that the most important one to us is the driving event. We really want to own that event. We really want the crowd to be excited because I think it really does inspire wonder. We could say that disaster response, humanitarian assistance is a noble thing. It's not just about being noble, it is our responsibility. And whatever technologies, whether you call it robotics or there's some other technology, anything that's going to help devastated communities because of a disaster quickly back to their feet, isn't that a call to everybody, regardless of, you know, color, creed, you know, nation? So to see that there is a global participation shows an awareness, and that's something, you know, we really applaud. I think it really needs to be continued. That message needs to continue on, you know, just generation and to the next one.
Well, once again, a closer look at Metal Rebel and that team. Their finals is now officially done as we check back in on red, and it's Warner trying to complete the valve task. That would be good for a 4th point. An impressive performance from Warner there to earn that 4th point. We'll continue to track the progress of Warner the Robot on the red course. In this round number 5, though, we have a new leader in Team Keist. They finished all 8 tasks in 44 minutes, 28 seconds. We also saw a new second place team emerge in this round, Team IHMC Robotics. They also completed all 8 tasks, 50 minutes, 26 seconds. But because these teams went so fast, specifically Team Keist, which is now the new leader and the front runner to win the $2 million, we thought you'd give you an idea, a better idea of who makes up Team Keist.
My name is Jung Ho. I represent Team Keist. When I was young, there are so many animation about the robot. It's kind of humanoid. In Korea, the Taecon V is a very famous robot. But I don't think there is reality, just animation. When I was in a university student, there is a kind of science exhibition. There is a KHR-1 robot made it by Keist. Our robot is very unique because it can transform from the standing position to the bipedal walking to the kneeling pose. And also he has a more powerful joint. It's just a motor, but we equip the air conditioning system on that. We make the hardware, whole software, we redesign or we remade it. We prepare 9 or 10 hours every day minimum. We're struggling every day. Everything is challenging, but the most is driving and egress, and walking is also. Pedal walking is very dangerous and very difficult to the human eyes. So it's very challenging. We have a passion, the pride for the technology in South Korea. They have a very cheering and supporting us. They want to see the very successful performance in final. We're gonna show you a good performance in the final. The government and South Korean, they have a pride. They have pride of us. They're really proud of our technology. We want to try to be one of the best team. They're gonna be happy, really happy. Actually, the DRC final is Olympics of robotics engineering. So we are the engineers. So we want to be the best in our region. I really want to be a winner.
Well, the good news is Team Keist is in the lead, so they got a great opportunity to win this thing. Once again, they completed all 8 tasks, 44 minutes, 26 seconds. If you want to keep up with the most up-to-date real-time scoring, all you have to do, download the DRC Finals app, available for Android and iOS phones. Also has a schedule of what's happening over at the Expo. In fact, in about 15 minutes time in the responder demo area of the Expo, AERO Robotics, in conjunction with Carnegie Mellon, has developed a modular robot for inspection and maneuvering. You'll be able to see different configurations, form into a snake robot that can climb poles, navigate clutter as well. Certainly worth a look, once again at 4:45. Mention how fast some of the competitors in round number 5 competed. Team Keist, obviously, is now your new leader. I made reference to this before, but Running Man, a very popular robot here, in second place, 50 minutes, 26 seconds. Remember, first place, $2 million. Second place, $1 million. And then third place will pick up $500,000. You can see those updated standings right now on the Jumbotrons. Just in case you're wondering how some of those other robots did, Tartan Rescue did earn 8 points yesterday. It was the only robot in day number 1 that picked up all 8 tasks. But the fastest robot that we saw was Team Nimbro Rescue. It'll be interesting to see if they're able to pick up some points. 7 points they earned yesterday in just 34 minutes. As once again, we take a closer look at Warner the Robot on red, trying to complete the wall task. Yesterday, that was the task it did not complete. It did earn 7 points in just under an hour. So once again on the red track, Warner the robot dropped the drill. Should be noted, yesterday that was the only task it did not complete. It did earn 7 points, so instead it now moves over to the surprise task. You've seen it done before, just in case you're just heading into the grandstand area. Surprise task requires a lot of manipulation here. On Thursday during the rehearsal day, it was a push button. Yesterday on round number 1, it was a pull switch down. And then today, it's probably the most difficult of the task. It's a pull plug on the left, and then you have to plug it back in on the right side. Now, Warner's having some success here. We already saw in this round Team Keist accomplish something, and that's earned first place after, or at least at this juncture, of the finals. Let's take a closer look at some of the other success stories we've seen so far in the DARPA Robotics Challenge. So Warner the robot earning a 6 point with the rubble task now complete. Potentially can earn a 7th if it's able to make its way up the stairs. And yesterday it did earn 7 points. Only task that it missed was the wall. Oddly enough, also what it was not able to complete today. All right, as we continue to take a look at Warner the Robot over on the red track, let's just get you updated here. We are shortly, about a minute away from starting our final round, just to keep you updated on who's going to be going when. Robo Simeon will be taken off on the blue track. And then Tartan Rescue Chimp, who was the only robot to finish all tasks yesterday, was previously your leader, has now been surpassed by Team Keist and IHMC Robotics. They will take off in just a couple seconds here, and then coming up at 5:30, Team Nimbo Rescue on red and Team MIT on yellow. All right, let's take you to the blue course right now and get our first look at Robo Simeon. Hailing from right here in Pasadena, California. Completed all the tasks yesterday, 7 points. It earned 47 minutes, 59 seconds. Check back in on those sixth and final round, but one last look at Warner the Robot earning the point, climbing the stairs. So 7 points, and their round is done. We'll head now to the green course. Tartan Rescue Chimp, the robot, inching a little bit closer to that finish line. Completed all those tasks, a popular robot yesterday. Only robot in the field to fall and successfully get back up. It's the second time today that the barriers have been needed. Take you to the blue course now. Robo Simeon also on the move. Only task it did not complete was the stairs. Yesterday, successful in everything else, earning those 7 points. It was actually in third place after round number 1. Had those 7 points in 47 minutes and 59 seconds. So a point, Robo Simeon now on the board. So over on the blue track, Robo Simeon just creeping inside that safe zone area and will earn a point on the second task with egress. The next task ahead will be the door, and there's officially that point. Robo Simeon now staring down the door task, and Sarah standing by with one of the team members.
Yes, I am, Mike. Dr. Katie Bell, and it is certainly a lot of excitement here. And can you just real quick describe the unique way that Robo Simeon maneuvered through that last task?
Right. Well, this is a task where Robo Simeon really excels, because you can almost think about that chassis that the car has as being like a jungle gym, almost like a ladder that it's climbing out of. That's something we thought would be the toughest part of the DARPA Robotics Challenge, but because we thought about it and planned, it's now, in fact, the most reliable thing that we do, and it's always a pleasure to watch.
Just to elaborate on that, you said something you planned on, so you kind of strategize what you need to do for each task with the robots, but how much emphasis did you put on that as opposed to, for example, the stairs, the one task, unfortunately, you guys did not complete yesterday?
That's a great question. We definitely triaged how we put on our efforts, so we're really focusing on the early parts where we have to drive and get out of the car. This robot would definitely be able to go up the stairs. The design is perfect for it. The software needs a little bit more testing to be robust. We didn't try the stairs yesterday simply because we didn't want to take the risk. But the plan now is that we will attempt them today, so let's keep our fingers crossed and see what happens.
As we continue to watch Robo Simeon and just this robot in particular, what's your vision? What more do you see potentially happening and that you would like to continue to do to this robot?
What I really think are a few strengths are that Robo Simeon is so strong. It's designed as a robot that's capable of doing pull-ups, that it has so many degrees of freedom, so the same limbs are dual purpose for either locomotion or manipulation. That the robot would be capable in variable conditions. So the teams have had a good idea for the past 18 months or so about some of the specifics of this environment. I'd really like to see robots be able to deal with a little bit more uncertainty. And speaking of uncertainty, the plug will probably be a little more challenging for us for the same reason that we haven't practiced it as much. But we'll see, we'll keep our fingers crossed.
Well, we appreciate your time. We know you want your eyes fully on Robo Simeon right now, so we'll let you get back to that. Thanks again.
Thanks, Sarah.
All right, Mike, back to you.
All right, Sarah, so once again, Robo Simeon, good to get a better sense of this robotic team, and as the robot continues to creep through that door and potentially earn a third point, just got across that yellow line. So a third point on the blue track for Robo Simeon. And if you were concerned about what was happening to Chimp, the robot from Tartan Rescue, who did complete the drive, the vehicle, the Polaris Ranger XP900, actually went into the barricade there. The team will not be penalized for a restart. So Robo Simeon with 3 points right now. It's a good time to sort of give you some perspective on what's making this challenge so difficult for a lot of these robots as we take a look at the team garage and what exactly the representatives are actually looking at with Robo Simeon. Once the drive takes place, the egress, and then getting to the door, the communication with the team garage and the robots are perfect, no issues. We're trying to mimic disaster type situations, so as soon as they get through that door, degraded communication sort of kicks in. So to give you some idea of what exactly that means, just imagine you're on your cell phone talking to someone, you're only hearing every couple words for a couple minutes there. It makes it really hard to understand. So right now, it's the robots that handle their autonomy the best are the ones that really are successful. So if you're in a club and it's dark and a strobe light goes off, you only get sort of that one quick flash to see what's around you. And that's exactly what's happening right now as soon as they cross through that door. For about 30 seconds, they're essentially seeing black, but for a quick frame, the team representatives are getting an idea of what's to come. As you take a look at the valve, so with the 360-degree turn, make it now 4 points. For Robo Simeon. So just to finish up that point, as the hour progresses, the degraded communication actually gets better. So as soon as they get through the door, the valve task, for example, is fairly difficult because of the lack of communication. But essentially the robots create a virtual map of the room and then are expected to go and execute a lot of these commands. Let's get a closer look at Team Robo Simeon.
I'm Paul Backus. I'm with Jet Propulsion Laboratory, and we're with Team Robo Simeon. Well, we think Robo Simeon's unique in that first, of course, we're walking on 4 limbs. We're not trying to walk on 2 limbs. But also a unique feature of Robo Simeon is that it only has one actuator that's replicated 28 times to minimize the complexity of the robot. That really comes from our general philosophy at JPL in that we work for NASA, that we want to build mechanisms that can accomplish the task, but with the minimum complexities. Everyone that I know is really excited about the whole competition. They're excited about what we're doing at JPL in robotics in general, but this is really something that the public can relate to. These robots from around the country and around the world competing with each other, doing really amazing tasks. We think Robo Simeon is going to perform very well in the DRC finals, partly because from the outset, we purposely made it a 4-limbed robot so that the mobility aspect was less risky than the bipedal locomotion. These other teams are great and really talented, but they're given themselves an incredible challenge of having to have bipedal locomotion. Because we can then traverse more easily, we spend more time developing the technologies for the other tasks, such as the valve and the cutting at the wall. That gives us some level of confidence that we'll be able to perform well. After the finals is over, we have a lot of great ideas for how we might use Robo Simeon. And that's one thing about robotics, is it's really growing in the different kinds of applications that you can apply it to. Robo Simeon's here being used on the ground, but we're looking at potentially under the ocean. We're looking at using it in space.
Certainly can understand the confidence from Team Robo Simeon as they look to complete the wall task now. So far, perfect going through the challenges. The drive successful, egress, as well as the door and the valve challenge. For the wall, robot has to pull a cordless drill off of the shelf and then drill through a 1/2-inch thick drywall. They have to remove that circle, that dark circle that's there, You score the point, doesn't matter how big the circle is that you're drilling, as long as you don't hit those frames, but you do have to punch it through, so there's an empty space. So just to keep you updated as we watch Robo Simeon try to complete the wall task over on the green course, Chimp, the Tartan rescue robot, will begin its egress. It will not incur a penalty. It'll just pick up from the time it was at. It's supposed to start egressing in just moments. And we're also expecting to see some action on the yellow track in just a few minutes. And over on yellow, it is Team MIT. That's supposed to be taken off shortly. Let's make our way over to the green course where Chimp is beginning its egress. Once again, no penalty after hitting that barrier and then needing a little bit of a reset here. They'll pick up right from their time after they were crossing that finish line to the point of the issue that they were having. Meanwhile, also on yellow, it's Team MIT taking off. They did do the drive successful yesterday, did the MIT squad. What they did not complete, though, was egress and the wall. Or excuse me, they did perform egress. Initially, it was ruled just a 6-point performance. The robot did fall out of the car, but it did land in that safe zone. So by rule, even though it wasn't a pretty dismount, they still earned that point. So on yellow, Team MIT earning its first point. As I previously just mentioned, Team MIT fell on the dismount yesterday, but still was able to be awarded a point. As we take a closer look at Chimp on the green track, beginning its egress, working its way out of the Polaris. Take a closer look at what's happening on the blue course with Robo Simeon trying to complete the wall task, and as you can see, still plenty of black in that region. All of the black needs to be gone to be awarded that point. Saw this happen yesterday in round number 1, where there was a team that had about that much, spent a lot of time trying to drill out that circle. They ended up just giving up on the task. We'll see if Robo Simeon's going to be able to punch that out and then drill another section of the circle out of the drywall. Back to green we go, where the Tartan Rescue Squad, the only team that was able to finish all 8 tasks yesterday, working its way out of the car. Remember, egress, not just getting out of the car, but finding your way into that safety zone. You'll see the yellow markings right outside the door. Once the robot gets into that region, they'll be rewarded with a point. Going to move over to the yellow track right now, Team MIT, beginning the egress portion of the task. And some good adjustments over on the blue track from Robo Simeon. On the initial drill, it looked like it was going to be leaving a piece of the black circle. As we take a closer look on the blue, let's see if it's making the adjustments necessary. Back to yellow we go. Team MIT, 1 foot down. Need another one to get into that safety area. And over on the green track, Robo Simeon just creeping into that safety zone. So another point there for Robo Simeon. Very impressive when you consider the degraded communication. We're still waiting official word from DARPA officials whether or not they're going to award the point, but just for fun, we'll just keep drilling into that drywall. Both on green and yellow, Chimp and Team MIT. They both earned 2 points. A potential third now coming on the door task. Takes you to yellow, or Team MIT. Remember to earn the point, not just open the door. You have to cross that yellow line at the bottom of the frame. It's a good first step. So another point for Team MIT as they creep through that door. Still waiting on the green track for Robo Simeon to do that. Meanwhile, over on red, off to the races we go. Mamaro is the name of the robot. The team is Nimbro Rescue. Yesterday, they clocked the fastest time for 7 points, 34 minutes, so not shocking here that Mamaro is doing a very good job driving. If my memory serves me correct, the fastest drive time yesterday came from Nimbro Rescue. only task that Momaro did not complete, and that's the robot on the red track that we're talking about, was the stairs. And another point here. For Momaro, very quick. It'll begin the egress now. Over on yellow, Team MIT trying to earn a 4th point on the valve task. Let's not forget, you got to rotate it 360 degrees. There's the black tape at the top as your indicating point. And apparently on the blue track, Robo Simeon was not awarded that point for the wall, so they continued to drill there. So another point awarded to Team MIT. Here are the cheers on blue. Robo Simeon continues to drill on the wall, but let's head back to the yellow track. Sarah's standing by with Team MIT.
That's joined by Russ Tedrick, and first of all, just how would you evaluate the progress so far by your robot after we just heard the big cheers for the point?
I'm feeling great. I am so happy to have seen that egress. We've been working so hard on that. Those of you that were here yesterday might have remembered we egressed face first last time. We broke our arm in that process. And we ended up going through the rest of the challenge with a broken right arm, which was unfortunate because we tried to do all the tasks with the right arm. So I'm very proud, though. We were able to just flip a bit in the software, and the robot was capable of doing almost all the tasks with its left arm.
How surprising was it for you to actually see the robot do that and to accomplish the task that it did, given it had a broken arm?
Well, so we knew it was possible, and the operators are fantastic, and the software is fantastic. The only question was how much time it was going to take, and well, we actually hadn't tested that. So, so to see it go all the way through was fantastic.
And we've talked so much, and we've heard Mike talk about the degraded comm that these robots have to face. How would you evaluate the autonomy of your robot to this point and just what it's been able to do throughout this challenge?
So we've been focused on the autonomy, maybe to a fault. We've been really trying to make the robot use planning in every stage, and we really do very little teleoperation. So most of the time when the robot's running, the humans are just watching what he's doing a few clicks to tell him there's a drill over here, go pick it up, but the robot's doing most of the work.
All right, Russ, we appreciate your time. You know, you want to get back to work. Good luck as you guys continue.
Thank you.
Now over on the green track, Sarah, the Tartan Rescue Team earning a point, getting through that door. As we just heard about Team MIT, they finished yesterday that round with just 6 points. They protested to DARPA officials, saying after that fall in the egress, they actually fell into the safe zone, that they should be rewarded a 7th point. DARPA officials agreed, and they earned that point. Meanwhile, as we take a closer look at Chimp, officially now a point scored on the green track for Chimps, making that now 4 points. From green to blue, RoboSimio now at the surprise task. Last 3 days, it's been a different task during the rehearsal on Thursday, which set the initial seeding. There was a push button off switch. Yesterday in round number 1, it was a pull down switch. And then today, arguably the most difficult of the 3 surprises, that's a pull plug. And then you have to reinsert it into the second outlet on the right side in order to earn the point. So a tough break there for Robo Simeon. Going to try to rally and regroup. Meanwhile, over on the red track, excuse me, over on the green course, I should say, Tartan Rescue also on the surprise task. Trying to do what Robo Simeon could not just accomplish. Standing by with Tartan Rescue members, here's Sarah.
Thanks, Mike. Yeah, Tony Stentz, who we're watching closely as we just saw Robo Simeon drop the plug, Chimp about to try to do the same thing. Can you explain to us why this is so challenging for the robots?
This is challenging because the robot needs to grab the plug without knocking it loose. If it drops the plug, it's very difficult to retrieve it. So the key is to get a solid grasp and then move it over to the other plug, get it aligned, and push it in.
As we continue to watch intently, Chimp holding on to this plug, how do you assess the progress so far of what he's done?
I think the Chimp's progress is reasonable so far. Plug is one of the harder tasks. Wall is also hard. So I think the harder parts are still ahead.
And Chimp has become a fan favorite, and certainly was yesterday after falling, able to get up on its own. What was going through your guys' minds as you were watching that and able to see him accomplish that task?
I was not certain that we were going to be able to get up after we fell, but I think due to the experience of the team and their commitment to solving problems, that they found a way to get the robot in a configuration where it could stand again.
All right, Tony, I know this is a tense time for you and your team, so we're going to let you continue watching and certainly appreciate your time.
Thank you.
All right, Mike, back over to you.
All right, Saria, so Chimp just trying to get that plug in as we check in very quickly, though, on the blue course with Robo Simeon. Saw them drop that plug, so they've decided to punt on that challenge. Meanwhile, go through the rubble here. You have a couple options. You could try to pick up the debris. None of it's more than 5 pounds. You can push right through it if that's what works for you. Climb it or walk over it. Same goes for the cinder block side. We'll quickly check in on the green track right now with Chimp. Something to be noted, you take the best time and the best finish after round 1 and round 2, and that's the score that you go into. So after round number 1, Tartan Rescue, this talk more about that in a second, but back to blue we go. Robo Simeon flexing its muscles, getting right through that debris, earning the point. It's now a 6 points. Let's take you to yellow. We haven't checked in on Team MIT in just a bit, but trying to complete the wall task. It has so far successfully earned 4 consecutive points. The drive, egress, door, valve, and now the wall. Check back in on Team MIT in just a few moments here, but we'll shift our attention to the green track where Chimp is still working on the surprise task. Point I was trying to make before, after round number 1, the Tartan Rescue Team, which is what you're looking at on the large screen on the green track, they did have 8 points, and they did in 55 minutes, 15 seconds. Right now, that puts them in 3rd place. After round number 1, it put them in 1st. Remember, top 3 finishes here at the challenge will earn money, $2 million, $1 million, and $500,000. We'll move over to the blue track. Back to Robo Simeon we go. Robots earn 6 points. We'll see if it can accomplish the stairs task. That was the one task it did not complete yesterday. As we heard during the interview that Sarah conducted a little while ago, that was more of a safety precaution to make sure that nothing broke. Hurt some robots. In fact, Team MIT, we just found out they had a broken left arm after the fall that it took, and it was still able to complete a total of 7 tasks. Certainly impressive considering that. Large fan contingent for Robo Simeon. The round is officially over for them. Move over back to the green track. Chimp's still working on the surprise task. Just to recap on Robo Simeon yesterday. Oh. Over on yellow, Team MIT taking a spill. Learned earlier it broke its left arm after a fall on egress yesterday. I think Team MIT is hoping nothing is broken on this particular fall. Let's check back on green with Chimp. Very close to finishing off this task. Who? Check back in on green, and the point has officially been awarded for the surprise task. That's inside the team garage for Tartan Rescue. You can see some stressful faces in there. It's now 5 points. Remember, they skipped the wall portion. Degraded communication, it's going to improve now as this hour continues, so I wonder if Chimp is going to circle back to wall or if they're going to decide to take on the Rubble Challenge. Saw some of those serious faces inside that team garage. Let's learn more about Tartan Rescue.
Unique robot. We decided that we needed a robot that had human form so that it would fit in all the same places that humans fit in and could do the sorts of things that humans do. But we did not want a robot that would have to balance. We didn't like the idea that the robot would have to walk. So instead of walking, Chimp rolls around on tracks. Since the trials, we've mostly worked on improvements to the software. We have been working on adding more autonomy to the system so that the robot will be faster by doing more things itself, so that it will be more robust to restrictions on communications, since it will be more difficult for a person to communicate with the robot. I see a number of challenges. The biggest one remaining for us is doing all of the tasks within the 1 hour time limit. It still takes quite some time for Chimp to perform each individual task, and we are accelerating the pace of our development so that Chimp gets faster. Carnegie Mellon is very excited about Chimp and about the Robotics Challenge. It is a very high-profile project. It attracts a lot of interest. When we are practicing the tasks, a lot of people stop as they walk by and they watch the robot go through the motions. Once the finals are over, we see a lot of potential for the technology we developed. For instance, it could be used in removing people from dangerous areas and have them control robots from a safe distance. It can also be used for advanced manufacturing to lower the costs of goods. I think our team will win the DRC finals because we have a great robot and we have great software technology, but most importantly, we have great people who are working on the team.
So there was a closer look at the Tartan Rescue robot. Just to keep you updated on what's happening on the other tracks, over on red, Team Nimbro Rescue going to take a reset penalty. And in the process, will punt on the egress point. Pretty significant considering the time that they made yesterday. 34 minutes, earned 7 points. Thought they were one of the teams that maybe could win this. Head to the yellow track right now. It's Team MIT off of its reset. So good news for Team MIT. Off of the reset yesterday after a fall, we learned that they broke the left arm of the robot. Take a spill here, they get the reset, so they'll take the 10-minute penalty, but it looks like at least they're functional to try to complete this course. Sarah Kustok, back with me on the set. You've been roaming the expo, doing the interviews down there. This has been an exciting day for you.
It has. And the expo, as we know, is so fascinating to see all the different types of robotics out there. But these last couple hours with these runs and being here on the track is what's been most exciting, as teams really have shown the improvements, the changes, adjustments they made since the runs yesterday, and now in ways which they're finding, in many cases, more success here on this final day of our finals.
I know you had an opportunity to talk to some of the folks for Team MIT. Here's a closer look at their squad.
My name is Russ Tedrick. I'm from MIT, the Computer Science and Artificial Intelligence Laboratory. I'm here representing Team MIT. MIT is really trying to emphasize the autonomy aspect of the challenge. With bandwidth concerns, we've always thought that the big challenge here is to try to do these tasks as autonomously as possible. So we've put a lot of emphasis in on the software, on the planning. So when our robot looks at a set of stairs or a ladder or a debris pile, it's actually planning on the fly, whole body motions that it's never planned before. What you saw in the trials, I think, was sort of a comfortable, slow, safe approach to the tasks. And so we've been thinking about how do you make everything faster and more robust. You get faster in two basic ways. We get faster by having the robot moving all the time. The other way that we make the robot faster is just when he's moving faster. He's walking faster, he's moving his arms faster. That requires more mastery of the control of the robot, more aggressive plans that think about the mass you're moving. The most frightening task for us is this driving and egress task. That's going to be a scary task. And I really look forward to the surprise manipulation task, just because I think that's the kind of place where the software we've written could potentially really shine. We're very open now with our approach. I think it's the right thing to do because ultimately the goal here is to contribute to the state of the art in robotics. I think the code we've written is fantastic. I'm very proud of it. I'm really excited by the fact that Google saw something in the robots competing in this challenge and decided that it was time for a major investment. This is the age of robots. I mean, we've never seen such a massive investment from industry as we've seen over the last 18 months. This is sort of the time for robots.
Sarah, I know you spent some time talking to representatives of Team MIT. We'll get to them in just a second, but let's shift our attention from yellow now to the red track. That's Team Nimbro Rescue. Just earning a point moments ago, a successful drive. Couldn't accomplish the egress, instead taking the penalty on a reset. But they did get through that door. Now they're eyeing down the valve. This is one of the fastest teams, one of the most impressive teams we saw on day number one. Kind of thought they'd have a great chance of winning this, but with 3 8 scores up on the board, best they can do now is 7.
Yeah, but they showed, just a lot of excitement yesterday as well. You talk about the speed in which they have moved. The only task they did not accomplish yesterday was the wall, and now you mentioned the egress, but it's been fun to see the way in which it's been moving. And as you said, one thing we know with the finals, unlike the trials, speed has been an emphasis, and Nimbro Rescue has shown a propensity to be able to move very quickly through these tasks.
You know, it's funny, I know you've talked to a lot of the team representatives, and we continue to hammer this point home about the degraded communication and how difficult it is to manage it. Give me some perspective on what some of the teams are saying to you about that aspect of this challenge.
Well, each one has a different perspective, and we just saw from Team MIT, Russ Tedrick explain more about his team. He said it in that piece that autonomy was a focus for them, and obviously that's what these type of innovations and the robots are moving towards, these robots to be able to function on their own when they don't necessarily have communication or good communication with the team in their garage, and we've seen that so far with many of these robots, the stop and go. But these past couple of races and these previous few hours, they haven't been moving as slowly as we expected, so you could see the improvements and the advancements in knowing what to do and being able to accomplish things on their own.
So on the large Jumbotron, we're talking about the degraded communication, and right now Team Nimbro Rescue dealing with some of those issues, but seem like they're navigating it pretty well, getting through the door and now the valve, just a couple rotations maybe here. Got to go a full 360 degrees. The indicator is a piece of black tape that starts at the 12 o'clock position on the valve. Should also be noted that over on the yellow track, Team MIT, coming off of the reset, is now making its way to the rubble section to try to earn a point on that 7th task. That would be a 5th point overall for them, as Mamaro, the robot from Team Nimbro Rescue, picking up point on the valve. Sarah, what else is pretty also nice to see is the fan support and also the excitement with a lot of these robots. And even when we go back into the team garage and see some of the videos, when they complete a task, not every single time, but some of them, you can see genuine excitement from a lot of these team members.
Well, and especially with the team members, and as we've talked to them throughout these past couple days, this isn't just something that they've been doing for the past few weeks. It's robots that they've worked with over the years, seen the improvements. They poured blood, sweat, and tears into creating what we see here today. So it deserves a lot of passion. It deserves excitement when you really take into account what it is that these robots are able to do. And I know for the fans and the audience, as we appreciate them out here cheering, it's fun to watch. And anytime you can kind of add some liveliness to it. We've seen some hats and some costumes and things of that nature, but it just adds to the fun that we're experiencing here today.
Best costume you saw in the grandstands, what would it be?
The Running Man. The all blue.
I saw that. I would have gone with that as well, except what I saw on the backside, it was drawing a little too much attention to me.
Mike, it's hard for you not to draw attention to yourself, so that happens no matter what.
Let's focus in on Team MIT on the yellow track right now. 4 points already picked up. Had the one reset, which is a 10-minute penalty, but they're making their way through the rubble. Running that Atlas robot, 6 domestic teams using the Atlas robot, 1 international team, that's one from Hong Kong.
And we continue to watch these robots, and not on the track anymore is Robo Simeon. You speak of the passion, plenty of fans and excitement for that. But when we spoke with Dr. Katie Bell, representative of the team, she brought up an important point, and I think we see this in a lot of the teams of the robots. She said, despite the fact it has been years they've been working on the robots, not necessarily a lot of time to always make sure the robots are at the maximum peak performance for each of these tasks. So in some points, you got to prioritize what you're going to focus on. So as we've been able to see different robots able to accomplish different tasks with more ease, and it's interesting, and obviously just adds to the research, adds to the development of what different characteristics of these robots help with each task. And she said it's not always necessarily the same goal. You can find ways in disaster relief situations what robots are best suited and how to continue this type of development, research, and innovations for the future.
You talk about those innovations for the future, and it's a great point considering where these robots were back at the end of 2013 for the trials and what we're seeing now. We continue to talk about this point, but to do these tasks in succession was something they were not asked to do. To have a surprise task and have it be 3 different things in 3 different days, that's also an impressive feat for a lot of these teams. And over on yellow, it is official now. Team MIT earning a 5th point. So one last task still ahead for Team MIT. That would be the stairs. They did complete that task yesterday. The one task they did not complete was the wall task. Speaking of giving out some points, Sarah, we move to red, where Team Nimbro Rescue trying to deal with the surprise task. Skip the wall. Seen a couple robots struggle with this one. I know right before you did your Robo Simeon interview, drop with the plug, that's got to be frustrating.
Right, and when we got a chance to talk to a couple of these representatives, and particularly Tony Stentz, you know, we were speaking to him as Chimp was doing it, but he said that's the biggest part with the plug. It seems like with the surprise tasks, I don't mean to speculate, but this might be one of the most challenging. He said grasping onto the plug, making sure the robots have a good grasp, because if you do in fact drop that plug, the hardest part is a swinging cord, trying to make sure to locate that, track that down, pick it back up again as it hangs down to try and re-plug back in. So he said, you know, you're hoping and just praying that your robot is able to hold on to that cord and to the plug.
You know, it's a great point, because we've talked about the degraded communication and just knowing how difficult and precise that task happens to be. It's almost surprising that some of these robots have decided to skip the wall to go to the surprise task, just based off of how precise it has to be. That was part of the tactic yesterday, where we saw some teams skip wall because of the degraded communication, because it might be a little bit harder to see. They said, you know what, we'll go to some of those other spots first, collect some points, and then circle back. In this instance, I mean, it's hard either way with those two tasks sitting right in the middle of the course.
Absolutely, and a part of this as well, the strategy. What different tasks do you want to do in what order, and how that helps the communication, and you've got to wonder if, you know, back at the team garage or how they have practiced with the robots, what makes most sense for each of them.
Let's quickly focus our attention to Team MIT on the yellow course. Successfully mounting the stairs. That's now 6 points on the round for Team MIT. One shy of its total from yesterday. As soon as we left the red track, it was Mamaro able to score a point. All right, a closer look at the red track, Sarah, as Momaro, the robot from Nimbro Rescue, just trying to push through the debris. The debris not all that heavy. Nothing in there weighs more than 5 pounds. You have the option of rolling through it, walking over it, or even moving the debris. Not one robot has decided to move the debris, which probably makes a lot of sense because it sounds time consuming, but we can see just trying to push its way through.
And in many of these robots where we see the wheels at the bottom, we kind of see them take this route and be successful with it.
It's funny you mention that. Every robot that has wheels have opted to take the debris path. Anything that's got resembles more legs has gone with the cylinder blocks to the right. And it looks like Momaro's actually struggling here. Maybe got caught on something. All right, let's update you on what's happening on the green track right now. Tartan Rescue, Chimp the robot, just leaving on its own terms, Sarah.
He gone.
Looks like time has run out for Chimp, who finishes with 5 points in this round. Nothing to scoff at, because right now Tartan Rescue still sits in 3rd place after its round yesterday. It was the only robot to complete all 8 tasks, did it in 55 minutes, 15 seconds. Currently, that is still good for 3rd place. And if you're keeping tabs at home, still in the top 3, you still get a nice little check at the end of the day.
Absolutely, and very impressive. And still a very good showing here today, and we knew Chimp certainly did become a fan favorite throughout these 2 days, but when you have that to back up with what he did yesterday, knowing that you have those 8 points, as I said, good showing, impressive showing here today.
You know, some of the representatives that you spoke to said, hey, it was a conservative approach because you don't want to get your robot broken in the first round, which in some ways makes sense. But then you look at a performance like Tartan Rescue, and they are the only team that puts up 8 points. And guess what? Right now, they're still in the top 3, even with a less than stellar performance when you compare it to round number 1 that they had yesterday. We've, over the last 2 days, Sarah, gotten a closer look at a lot of these teams. You've had an opportunity to speak to a lot of them, but the fans don't always get that opportunity. So let's take a closer look at Team Nimbro Rescue that's on the red track right now.
My name is Sven Behnke of University of Bonn, Germany. I'm heading the Team Nimbro Rescue. Our robot is called Momaro, which stands for Mobile Manipulation Robot. What is unique about our robot is that it has more legs than most of the other robots. So it has 4 legs and in addition 2 arms for manipulation. And it's also equipped with wheels because we think the invention of the wheel was not the worst one. And it may make it easier to locomote on sort of flat terrain, but it can also step. With regards to the software, I think our approach is more cognitive than the software of many other teams. We deal a lot with 3D perception and planning, and not so much with the low-level control concepts. We participated in different robotic competitions, most notably RoboCup. And with the DARPA Robotics Challenge, I think this gives a lot of international visibility, and many of the top US universities participate in this kind of event. So we like to actually give them a challenge. Robotics in Germany is very strong in the industrial sector. Robots are supposed to help people with jobs that are dirty or dull or dangerous. And clearly, if you don't want to send a human, then you may send a robot. The current state of the technology is not that these kind of assistive robots are very helpful. And I think the DARPA Robotics Challenge is a good opportunity to advance the state of the art. We are here participating in the challenge, not necessarily for winning the challenge itself. We will gain some experience in the domain, and this will be a good basis for our future research.
Well, that was a closer look on the red track at Team Nimbro Rescue. This is the first time we're going to actually see this in the competition. Looks like Momaro, which is the name of the robot, has actually gotten something caught maybe in its wheel. We've never seen a robot try to move the debris, Sarah, and that's what it looks like is happening right now.
Yeah, it has almost a claw-like feature. It's pulled out of his arm, and as we see it start to move here, it appears to be successful, maybe just gain a little bit of leverage, a little bit of space from some of this debris to once again try and push through.
So Sarah, looks like a slight stumble here. I haven't seen Momaro actually try to conquer the stairs. We saw a little bit of that in that video, so you actually know from watching the video that that back wheel could potentially straighten out there and try to pick up the robot.
Yeah, good compensation here. And again, it's not a good word using stumble. It's not quite a fall. And you could see maybe some of the precautions, the adjustments that Momaro has to try and take a look at the garage as the team hard at work, I'm sure, trying to figure out exactly what to do, how to proceed from here.
Trying to figure out if the guy on the front left is actually taking a nap or using those virtual reality glasses.
Mike, if that were you, I know you would be taking a nap, but we know.
They've been working
with
some
all
long
these
days.
all these folks hard at work, they're used to it.
No, he's up. Some good support over on the red track from Momaro, the robot from Team Nimbro Rescue. And Sarah, it took some time there, but they were persistent, able to get through that rubble.
Yeah, excellent self-correction. And as you said, it did take some time, but what we saw, it was something that was very methodical, and the different capabilities. I mean, I think the interesting thing to watch here, and we've seen it with different robots, but the capabilities that it has, as we said, to self-correct, the autonomy of it, as we now see Momaro moving on.
The DARPA set, Sarah Kustok, Mike Yam with you. Round 2 officially now in the books as Momaro, the last robot that was competing on the red course, is officially now called it quits and is retired. So certainly an impressive 2 days here in terms of our coverage at this desk and you roaming not only the track but also the expo. 21 hours of live programming that we have done over the course of 2 days. So it's been a lot of volume to try to handle and figure out what sort of the key components were going to be over the course of these 2 days and who was going to shine. What's your biggest takeaway that you took away?
I feel like we came into this not really knowing what to expect. We knew the changes, the added elements. We saw what these robots were able to do in the trials. I just think the takeaway from me is just the improvements, the advancements, and it's incredible to think how far these teams have gotten these robots to this point. Now what's next? What's to come? And I think the future just looks so bright for the research and the advancements of so much of this technology.
You know, I know for me at least, preparing for this, you know, you spent so much time focusing on the robots that were competing for that $2 million prize, and yet all the demonstrations and some of the interviews that you were doing, seeing the technology that's already available and some of those advances, once again, very impressive and a great performance from a lot of these teams for this DARPA challenge. All right. $2 million, as I've continued to say over the last 2 days, is still on the line. That's going to be rewarded in about 15 minutes time. 7:20 we are expected to have the closing ceremonies. First, second, and third place, $2 million, $1 million, and then $500,000. So the closing ceremonies, once again, expected to start about 7:20 or so. And I made reference to the fact that you were roaming the expo. The best of the last 2 days, we have it for you right now.
There's thousands of people here coming to see the robots in the grandstands, but at the same time we have this gigantic expo area out here with all kinds of exhibits to help people learn about robotics, to learn about science and technology, and to learn about DARPA. There's about 80 booths here today with displays sponsored by companies, by universities, by nonprofit educational groups.
The expo is great. I think it gives the public an awareness of the capabilities that's within the national response system. The demonstration was regarding hazmat equipment that's utilized within the FEMA USAR system, the Urban Search and Rescue System.
One thing we'd like people to get from this exhibit and these demonstrations is how much international cooperation there is in this field and how we can all work together to bring this technology to fruition.
Today was a simulated collapse structure with a live victim. We actually demonstrated using a robotic snake. The robot had a camera on the end of it, and we were able to use the robot through a small hole to identify the location of the victim. And we were able to demolish the concrete around and then make access to the interior of the building, where we had to cut open some wood, and then that's when I crawled through the hole, found the victim, and I was able to relay that victim to my partner outside.
There's a lot of kids who are really interested in robotics. Science is the tool to the robotics, and math is a language to the science. So science and math cannot be more important. And when kids come here and they talk with the engineers, that's actually communicated. People see all what goes behind the robotics. So that's actually a very, very important message that this expo is bringing to the general public.
This expo is a wonderful way to inspire kids to get interested in science and technology, to play with some robots and some tools, and just get that sort of engineering feel so that they want to be the next doers and makers for the next generation.
Still 100% my favorite video that we have played, the agony of defeat, but there was plenty of triumph. Mike Yam, Sarah Kustok with you. There's a lot to celebrate. Closing ceremonies coming up in just a couple moments here. We'll finally find out $3.5 million, where it's going to go. But it's really, Sarah, at this point, it's more than just the dollars.
It is, and that was a common theme from the start of these finals, and it's continued on no matter who you talk to. The humanitarian aspect, what these robots are really trying to accomplish, big picture, saving human lives, what they can do for this world, and we know at the end of the day, that's what they're really pushing for.
I know we have a sizable crowd right by that stage, all 23 teams ready to rock and roll. Let's send it down there, and a couple quick introductions for some people that will be heading to the stage from DARPA. The director of DARPA, Arthi Prabraka, is going to be there. The deputy director of DARPA, that's Steve Walker. The director of the Tactical Technology Office, Brad Towsley, and the deputy director of that Tactical Technology Office, Pam Melroy.
Here we are at the magnificent end of the DARPA Robotics Challenge. How great to see everybody here. So we have had just an extraordinary 2 days. It's been an astounding 2 days. Every single stumble we just felt, it broke our hearts. Every success caused our spirits to soar, and it's just been terrific to share it with all of you. So the first thing I want to do tonight is celebrate all of our, wave your hands, stand to all of our teams. Let's hear it for our teams. Terrific to see all of you. Today's the end of the DARPA Robotics Challenge. For all of you, it's the beginning. Lies ahead. And you are going to be the vanguard. This new future that you're going to go build that allows us to have robots out in this unstructured environment. We've got people here. Students, we have people who are part of companies large and small, we have people from labs of every possible variety, we have people here from countries, and every single one of you made an amazing contribution to the field of robotics. You've done some extraordinary things, but this is just the beginning. For a generation out ahead of you, you're going to be running with each other, you're going to be working with each other. Swap it out. You're going to have the opportunity to build an entire field, and as you do that, I know you're going to think back to 2015 here in Pomona, California, the end of the DRC and the beginning of a huge journey. So congratulations to all of you. Thanks so much. We're going to celebrate a few more people. I want all our guests and visitors, everyone who came to participate, stand up. Thank you so much for being here with us. Thank you so much for joining us. You got to be part of history. Thank you so much for cheering us on. I want to particularly recognize our guests who came from countries outside the United States. Who's here from the international community who came from other countries? Please stand up. Please join us. Thank you. Thank you. Thank you. Thank you so much for coming. It's such a privilege to get to do this with all of you. Next, I want to thank the DARPA staff, huge numbers of people from DARPA and our support staff and the production crews. Please stand up. You've been watching these amazing videos. The amount of work that these people have done is exceptional. Thank every one of you for your work. None of us could have done this without the City of Pomona and the people here at the Fairplex, the tremendous staff that's helped make this work, the emergency response teams, the firefighters that have been here, all the support staff. Wave your hands. We want to thank you. Stand up and wave your hands. Thank you so much for everything you've done. I want to talk about Gil Pratt's DRC program team. Stand up and wave your hands. You all have helped design this amazing event. You built this tremendous competition. You helped make this happen. Thank you so much, all of you. I'm on stage tonight with some of the leadership of DARPA, and starting on this side, this is my deputy, Steve Walker. Everybody knows the next guy here in line, Gil Pratt. And standing next to Gil is Brad Towsley, who runs our Tactical Technologies office. And next to him is Pam Melroy, who's Deputy Director of TTO as well. It's great. For all of you that made this happen, I just want you to know that for me, for Steve, for Brad and Pam, and for Gil, it's been such an honor to be associated with you. Thanks so much for making this a real event. Thank you. It's a privilege. All right, I'm going to finish by giving my biggest thank you of all, and that's to Gil Pratt. You all have worked with him. The teams have worked with him for an extended period of time. The team he put together to make this event has had the opportunity to work with him for an exceptional period of time as well. Gil Pratt is something amazing, and that amazing thing that he is a DARPA program manager. That's a person who gets to have a vision, who gets to build a team to go do it, who has the privilege of inspiring an enormous community and sparking a new revolution in technology. And I want to thank Gil for having demonstrated to the world what a DARPA program manager is all about. Thank you, Gil. Woo! All right, now what we get to do tonight is to celebrate and congratulate our 3 top winners of this amazing competition, and I'm now going to turn it over to Brad Towsley to introduce them to you.
So I get the distinct honor to introduce and welcome to the stage the 3 winners of the DARPA Robotics Challenge Finals. And we'll start with 3rd place, $500,000 prize. Yeah, that's a big deal. From lovely Western Pennsylvania, Tartan Rescue. Well, that's an awesome team. They did an awesome job. $500,000 prize. Next up, we're going to go south a little bit from Pittsburgh, Pennsylvania. The 2nd place prize for the DARPA Robotics Challenge Finals goes to the team from Pensacola, Florida, Team IHMC Robotics. So now we're going to go from Pensacola, Florida. I'm going to go across the United States and across the Pacific Ocean. In first place, DARPA Robotics Challenge Finals from Daejeon, South Korea, Team Keist.
So I would like to begin by doing something Arthi already did, but a little bit more. So I would like every person who's ever come to our bi-weekly DRC meetings, and you know who you are, to come up on the stage right now. That includes you, Mike. And as they're coming up, please give them a hand, and it's going to be a long applause. All the SSC team, please. Dan, come on up. Where's Larry? Larry? Where's Larry? I'm looking for Larry. You know where Larry is? Larry. Where's Larry? Where's Larry? Larry Jackal. We're looking for you. Calling Larry Jackal. There he is. So up here, you see, and Larry's about to come up, a remarkable, remarkable team. This team is incredible. The mark of a good team is what they do when their leader isn't around. And as you may have known, I was busy up there giving interviews a whole lot of the time. And these guys made everything work. They not only made everything work today and yesterday and during the rehearsal, they made everything work for 3 years. And they built this entire thing from a time that Jim Pippin, where are you? Jim? Jim, come up here, Jim. This guy here, Jim Pippin and I, several years ago, it's such a blur now, I don't remember how many, we're sitting in the desert near 29 Palms in California under a tent that looked just like that. And we sat there with a laptop and a cell phone and a weak internet connection through the cell phone. And we talked about how to create this crazy challenge for robots. And the plan we ended up actually a lot bigger than what we had figured there, but that's the genesis of the whole thing. We still pinch ourselves every so often because we can't believe it actually happened. So, first of all, a huge hand for Jim, who was the chief of operations and made all this work.
Our staff, our volunteers.
Now, we're going to forgo taking each one of these guys up because my hand's really tired of shaking hands. But there's a whole bunch of other folks who supported us too. Arthi talked about them before. I'm going to say it again. These are the over 300, they're not all here right now because some of them are tired, DARPA and other agency staff that supported us. So all of you stand up, please. All of the DARPA staff, you all know who you are, that volunteered for this. So there is an extraordinary thing that happens when you realize, when you wake up and you go to work, that you are working for the best possible place. You're working for the right place. And that's when you call and you ask, who wants to come with us for a week out to the desert or out to some hot place in Florida and just volunteer to help run a robotics challenge? And the answer is a huge outpouring of support. They come here and all that they have is smiles. So thank you, thank you, thank you very, very much. So what have we done today? Have we finished the work to be done in robotics? No. Are we in the middle of the work to be done in robotics? No. Have we perhaps begun the work to be done in robotics? Yes. Okay. And we have begun it, I think, in an extraordinarily good way with tremendous dedication, with tremendous enthusiasm. And what we have done is we have shown the world a little bit, just a tiny bit, of what is possible. And we picked a particular application of robotics that I think is very, very close to everyone's heart, which is making the world safer from disasters. There's so much more work to do. I am sure that all of you are going to do a whole lot more of it in the coming years to come. You will remember this day as the beginning of that work. And I cannot wait to see what all of you will do in the future. So, before I end this, what I would like to do is remind you that we're not even done with this little event, because coming tomorrow is the workshop, and your reward for having come in first, second, and third place is that you now have to give a presentation tomorrow. And there will be a lunch. And being the professor that I am, I will give you homework, which is to create that presentation, and it better be good. We won't take away the checks, don't worry. And really try to tell the world what you did and how you did it, okay? That's really the thing to be done now. You have been tremendously collaborative. Many of you have opened up your source and given it to other teams and helped them. I've seen incredible collaboration in the team garages, which worked beautifully synergistically with the fierce competition that was going on as well. Many of you saw Jim and I running around between the courses during the last 2 sets of runs, making sure that everything was just perfect so that we really had a fair competition at the end. So once more, thank you to everybody that came here. Most of all, I want to thank the management of DARPA. Because they are the ones who said yes. They said yes to me, and ultimately they said yes to all of you, and they made this thing possible. So I'll put in one last pitch, and that is someday when you grow up, Jerry, you're kind of a little grown up now, I want you to seriously consider doing what I did and really take up the incredible privilege of coming to DARPA as a program manager, imagining what you want to do. It'll be something totally different, totally new, and having the incredible experience that I had. And with that, I want to once again say thank you to DARPA for making this all possible. Thank you.